Ghulam sir, please off your display.
Dear participant, we are going to start the inaugural session. Kindly please wait for some time.
From one person from the ICT in Vignana, I think so.
Yeah, a very good evening to everyone. With great delight and deep respect, I welcome you all to the inaugural session of the AICT-sponsored 6 days ATAL Online FDP on Joy of AI in Action, Applying Traditional and Agentic AI to Real-World Problems, scheduled from August 18th to August 23rd, 2025, organized by the Department of CSE, Cybersecurity, Data Science and AI&DS, VNR Vignana Jyothi Institute of Engineering and Technology, Hyderabad, Telangana, India. We are honored to host this event aimed at advanced learning, innovation, and research excellence in AI with a special focus on the emerging field of agentic AI. The program blends traditional AI techniques with cutting edge agentic approaches, showcasing their applications in solving real world challenges across education, industry, agriculture, healthcare, and society. Through expert talks, hands-on training, and collaborative activities, participants will gain insights into AI-driven innovation, ethical consideration, and effective implementation strategies. It also provides a vibrant platform for researchers, faculty, and professionals to share ideas and develop AI solutions that benefit both society and industry. At this moment, it is my privilege to invite our distinguished guests and dignitaries joining us virtually for this online FDP. Dr. C.D. Naidu, sir, Principal of VNR-CSECYSDSAIDS. Sir, under your visionary leadership, our institution continues to thrive. We warmly welcome you to this program. Dr. B. Chennakesava Rao, sir, Director of VNR-CSECYSDSAIDS, your gracious presence and guidance mean a lot to us. Dr. T. Sunil Kumar, sir, Professor and Head of the Department of CSE, Cybersecurity, Data Science, and AI&DS, your constant support has been instrumental in making this FDP possible. Myself, Rasmita Kumari Mohanty, Assistant Professor in the Department of CSE, Cybersecurity, Data Science, and AI&DS, and the Event Coordinator of this FDP. Mrs. N. Madhuri Ma'am, Assistant Professor and the Co-Coordinator of this FDP, I welcome and thank you for your contribution to organizing this event. This FDP comprises 13 lectures and hands-on sessions running from 6 p.m. to 9:30 p.m. from 18th to 22nd August and 2 p.m. to 8 p.m. on 23rd August 2025. Each session will be approximately 90 minutes long. On the last day, August 23rd at 6:30 p.m., we will conduct an MCQ test as per the AICTE guidelines. Certificates will be issued to those participants who attend all the 6-day session and successfully clear the test. The sessions span a wide spectrum including foundation of AI and traditional machine learning, applied LLM, NLP, and generative AI, introduction to agentic AI, frameworks and tool chains, deep learning applications in medical image segmentation, emerging security risks in AI, real-world use cases of traditional and agentic AI, explainable AI, case study on software reliability, industry perspectives and applications. These sessions are enriched with real-world case studies and open source tools, ensuring participants gain both theoretical grounding and practical exposure. We are proud to welcome 200 plus participants from various engineering colleges across the country. Our expert speakers represent prestigious institutions such as IIT Bhubaneswar, NIT Warangal, NIT Kurukshetra, ONGC Dehradun, along with two distinguished overseas speakers, Dr. Arijit Karati, National Sun Yat-sen University, Taiwan, Dr. Sandeep Singh Sengar, Cardiff Metropolitan University, UK. We sincerely thank AICTE for giving us opportunity to organize this ATAL 6 days online FDP program, and also I express heartfelt gratitude to the Vignana Jyothi Society, especially Sri D. Suresh Babu Garu, President, and Sri Kode Durga Prasad Garu, retired IPS Officer, General Secretary, as well as our respected Head of the Department for their continuous encouragement and support. I request all the participants to actively engage in this all 6-day session, interact with our speakers, and take full advantage of this rare learning opportunity. Let us work together to make this FDP a memorable and impactful event that inspires innovation, collaboration, and excellence in AI. Wishing you all a productive and enriching week ahead. Thank you. I now request our respected professor and head of the Department of CSE, Cybersecurity, Data Science, and AI&DS, Professor and Dr. T. Sunil Kumar, sir, to share his thoughts and vision with us. Over to you, sir.
Yeah, thank you, Mohanty. Respected Principal Sir, Dr. C.D. Naidu Garu, our Director, and also the leader and visionary person, Dr. B. Nageswara Garu, Director for Dean Academics and also the Finance, Program Coordinators, Rasmita Kumari Mohanty, and also the Madhuri, our senior colleagues in the department, all our colleagues, online and offline, the eminent speakers, those who joined with us today online, and also the people from NIT Warangal who are the driving force behind this 6-day AICT training and learning academy and also the faculty development program, which we have been offering for the 6 days starting from today, that is 18th of this month today till 23rd. Specific timings that are very convenient for everybody to join, 6 to 9:30 every day evening. Very convenient time, I believe. I am Dr. T. Sunil Kumar, have been working as a professor and head of the department in the Department of CSE with the specialization programs, cyber security, data science, and AI&DS in Vallurupalli Nageswara Vignana Jyothi Institute of Engineering and Technology, Hyderabad, Telangana, India. We are privileged to offer this 6-day FDP as the second time. We are proud and I'm esteemed to say that this is the second ATAL FDP that we got chance to host from our department of our college, which we earlier conducted in the month of January 25, and within 8 months again we got a chance. I take this platform to express my heartfelt gratitude for AICTE and also NIT Warangal for their constant support and instrumental in giving us the opportunity. I welcome you all to this online 6-day FDP on the title Joy of AI in Action, that we need to apply the traditional and agentic AI to real world problems. We all know that real world problems are everywhere. Universe always throws the problems. As the researcher or academician, we need to address those problems. These are the platforms that we can make use of for collaborative learning so that we can build our skill set, expertise, so that we can apply all our skill set to address these problems on right time in the right approach to achieve the optimal solutions. To achieve so, I request all the participants to be active online. Since it is an online, it's a great opportunity for us to join from all the time to everywhere without any problem. However, a small fly in this ointment is that at the same time, we may also de-link from this session since it is online. Imagine if I sit in the classroom in front of the lecture, professor in the lecture, I have a constant focus to receive from the person to the receiver. If it is online, I have an option to put off my video and mute myself, and I may leave my device and go some time because of some work. So I sincerely request all the participants, since we have the flexibility to make use of these online platforms, which we can connect virtually irrespective of though we physically separated, please be active during the sessions because we have a very good expertise faculty that they have invited from the national to the international institutions let us not waste their time, please. And also let us learn from them. This can be assured only when really, if we really connect with them during the sessions. So I take this platform to express my sincere gratitude for our visionary management of Vignana Jyothi Society and also the VNR-CSECYSDSAIDS Engineering College, our President Sir, General Secretary Sir, those who are the group of people as the visionary management. We all work to achieve the services to the society with a motive of not for profit organization. With this note, since we are part of such a genuine and renowned service oriented engineering college, we, the Department of CSC, with the specializations of data science 180 intake, cybersecurity 120 intake, AI&DS 60 intake, we have been doing our research in the primary areas like artificial intelligence, machine learning, deep learning, quantum computing, image processing, blockchain technologies, Internet of Things, security in wireless networks, and also security in cloud computing and as well as edge computing. I am proud to say that 5 of our senior faculty have been pursuing their PhD from NIT Warangal, and 2 faculty have already completed their PhD from NIT Warangal, and one of them have been pursuing their postdoctoral fellowship in IIT Hyderabad. And also, so far, we have a total number of patents 35 plus in our department, and our faculty have been publishing their indexed journal papers in the reputed journals, and many of them are the editorial board members. And also the ongoing consultancy, where we have one in our records, and we are in the process of getting 2 more consultancies very soon in the department. And also we have the patents that already been published 35 number, but out of many of them are under progress towards the granting when we have been continuously working for further improvements. And I also say that our strength to improve on everyday basis is our students. We get in our department the creamy layer, top 2 to 3% of students that we get through our Telangana MSET, which are the best rankers. This year's all our seats have been filled with less than 3,000 in OC category, and our strength is that creamy layer students. So we have a project-based learning concept, and we involve our students in the teaching learning based on the project learning concept, and our faculty constantly work with their students. So with this note, what I'm trying to request the outside faculty, those who are joined with us, that overwhelming number of total 200 plus, and out of that nearly 80 to 70 plus faculty now joined. I request all faculty to connect with us on everyday basis and learn the things. And also, please, whenever you conduct such event, please let us know. We would like to take part in that. With that note, once again, I take this platform to congratulate all our coordinators who are instrumental, Rasmita, Kumari, Mohanty, and Madhuri, for their constant work on this, and also our management for their constant support, and also principal sir and director sir for their encouragement and support. Thank you for giving me this opportunity. I wish you let us learn collaboratively and have a great evening. Please stay connected throughout this session. Please don't mute your systems. Don't turn off your videos. Please don't go away from the devices. Wish you everybody a happy learning. Thank you very much once again. I request Mohanty, coordinator, to proceed with the next steps.
Thank you, sir. Your speech has truly set a thoughtful tone for the event. We are honored to have with us Dr. B. Chennakesava Rao, sir, Director of VNR-CSECYSDSAIDS. We invite you to address the gathering and share your valuable thoughts and guidance with us, sir.
So good evening to all of you. So on behalf of VNR-CSECYSDSAIDS, on my own behalf, I would like to express my heartfelt gratitude to AICTE and as well as the Department of Computer Science, Data Science, Cybersecurity and AI&DS under the guidance of Sunil Kumar Garu. and other faculty coordinators, Rasmita, Kumari, Mohanty, and as well as the Madhuri. All these people, I think they are instrumental in getting this FDP program during this 1 week, 18th to 23rd of this month. So as you're all aware that, so we are giving the top priority for faculty development programs because today I think the technology is growing at very fast rate. Today's technology is tomorrow's outdated technology. Unless we acquire the knowledge that we required in the emerging technologies like cyber security, AML, and deep learning, machine learning, and IoT, CSBS, computations and business systems. And as well as nowadays, I think everyone is talking about the quantum computing. So these are all the upcoming areas, edge computing and IoT, all these are all the upcoming areas. So I request all the participants to interact with the faculty members. I think we have drawn faculty from various premier institutions. So please try to attend all the sessions and acquire the knowledge that is required so that in turn, I think you can teach well in the classrooms. So today, I think agentic AI. So the theme of this FDP program is Joy of AI in Action, applying traditional and agentic AI to real world problems. Today, I think every way the problems are there, but how we are going to provide the solution. So whatever the solution that you are providing, it should be cost effective and economical, and as well as the effective utilization of that particular solution is very, very important. So the era of AI, I think definitely will look forward, especially in case of agentic AI, AI agent, generative AI. These are all the various tools normally we are going to use to improve the efficiency of AI. So as you are aware about that, the concepts and fundamentals that are very, very important. So I request all the teachers, please try to learn concepts as well as the fundamental knowledge in these domain experts, domain expertization. So that way I think you can implement all these tools effectively. So there are so many tools are available, but nowadays I think the students are very smart. They are learning quickly and they are implementing in their own day-to-day activities. But as a teacher, I think it is our duty to learn all these tools and try to implement wherever it's required. Because unless you do research in these areas and produce the quality products, so you need to have a domain knowledge also. That's why I think cross-domain knowledge is also very, very important. So please try to learn all these concepts. I think whatever the schedule that they have given, actually these 5 days, definitely 6 days, definitely it will help you to improve your knowledge in this particular domain. And those who are pursuing PhD, please try to interact with the experts, and whatever the queries that you have in your mind, so please try to discuss with experts and get their opinion also on the particular topic. And if at all anybody is struck off in that particular domain, so please try to acquire that knowledge during this 1 week and try to implement in your day-to-day activities. I hope you are going to enjoy this 1 week and you'll have a great learning, because in the evening, so without disturbing your classwork, you can attend all these sessions and try to acquire the new knowledge that you require. And in this connection, I would like to compliment both the coordinators. I think you have done extremely good job, and you have drawn the faculty from various premier institutions. So naturally, definitely, I think you can take more information from them and try to improve your knowledge in this particular domain. I wish you all good luck. You'll have a great learning. All the best. Thank you.
Thank you so much, sir, for providing valuable words to our participants. Now I request N. Madhuri ma'am to tell the vote of thanks.
It is my proud place to support the vote of thanks for this inaugural session of the ATAL Climate Movement Collectivity. on role of AI in management, applying of traditional and generative AI to real-world work. First, foremost,
No, kindly unmute yourself.
Excuse me, ma'am. I think you are in muted. Please unmute her and please continue the session.
It's on only, sir.
Now it's fine. Now it's fine, ma'am. Please continue.
A big thanks to AICT for sanctioning this FDP and to the Jyothi Society, particularly Sri D. Suresh Babu Garu, President, and Sri Kode Durga Prasad Garu, IPS Retired General Secretary, for their continued encouragement. I would also like to thank my colleagues and coordinator, Mrs. Rasmita Kumari Mohanty ma'am, for her sincere efforts in organizing this FDP smoothly. Most importantly, I extend my heartfelt gratitude to all 208 participants who have joined us from 13 different states across India, making this FDP truly national in spirit. Here is the state-wise participation. Telangana, 78 participants joined. Andhra Pradesh, 32. Tamil Nadu, 46 participants joined. And from other states like Odisha, Karnataka, Bihar, Gujarat, Haryana, Madhya Pradesh, Maharashtra, Pondicherry, Uttar Pradesh, and Uttarakhand. This diversity of participation reflects the wide reach and importance of our FDP. And we are deeply thankful to each one of you for being part of this journey. Important note to participants. Kindly join the FDP WhatsApp group to stay updated with announcement and resources. It is mandatory to fill the attendance Google form that will be shared during each session. As per AICTE guidelines, participants must maintain at least 80% attendance to be eligible for receiving the participation certificate. With this, we conclude the inauguration ceremony. I request all participants to stay connected as we now begin our first technical session of this FDP. Thank you, one and all. Wishing you a fruitful and insightful learning experience in the days ahead. Now, I would like to hand over the proceeding to our FDP coordinator, Mrs. Rasmita Kumari Mohanty, who will take forward the session schedule. Over to you, Rasmita ma'am.
Thank you, ma'am. With this, we conclude the inaugural ceremony. I now request all the participants to stay connected as we begin our first day of FDP session shortly. Thank you, and we wish you a fruitful and insightful learning experience ahead. Now, as we begin the FDP sessions, we are truly honored to welcome today's speaker, Dr. Sanjay Kumar Panda sir, to the first day of our 6 days ATAL FDP program. Sir, Sanjay sir.
Yeah, madam. Good evening, madam.
Yes, sir. Dr. Sanjay Kumar Panda is working as an assistant professor in the Department of CSE at NIT Warangal, Telangana, India, and founder and director of a startup company called Texamelon Private Limited. He received his PhD degree from IIT Dhanbad, Jharkhand, India, MTech degree from NIT Rourkela, Odisha, and BTech degree from VSSUT, Burla, Odisha, India in computer science and engineering. He has 12 years of teaching and research experience. He received 35 awards from IEEE, IEI, ISTE, CSI, and others, which include 2 silver medal awards for the Best Graduate and Best Postgraduate in CSE. IEI Young Engineers Award, Young Scientist, IEEE Senior Member, and CSI and ACM Distinguished Speaker. He is listed as one of the top 2% of the world scientists in a single year impact as per the survey conducted by Stanford University, USA, and elsewhere in October 2022, 2023, and 2024. He has published 170 plus papers in reputed journals and conferences and edited 7 books. He received an R&D project worth rupees 50 lakh from the National Supercomputing Mission IISc Bangalore under the DST Government of India and a Genesis project from the mighty Government of India. He is a member of IEEE, IEI, life member of ISTE and CSI. His current research interests include cloud and fog computing, artificial intelligence, machine learning, and the Internet of Things. He delivered 300 plus invited talks and chaired sessions at many national and international conferences. He has awarded 6 PhD scholars, 30 MTech scholars, and 49 BTech students, and guiding 11 PhD scholars. His Google Scholar citations reached 2,950 plus with an H index of 31 and an item index of 61. He acted as a reviewer in many reputed journals such as IEEE, ACM, Elsevier, Springer, and Hindley, and many reputed conferences. He also served as a guest editor in many international journals. Thank you so much, sir, for accepting our invitation. You can proceed your session, sir. Thank you so much.
Yeah, thank you very much, Professor Rasmita madam, for introducing me. And I would also like to thank Professor C.D. Naidu, Principal of VNR-CSECYSDSAIDS, Professor B.C. Rao, sir.
Sir, you are on mute. Please unmute yourself, sir. Sanjay, sir.
Yeah, it is already on mute, madam.
Yes, sir. You are audible, sir. Please continue.
Yeah, okay. So I would like to thank the Principal of VNR-CSECYSDSAIDS, Director for Advancement and Dean Admin, VNR-CSECYSDSAIDS, Professor T. Sunil Kumar, the Head of the Department of CSE, Cyber Security, Data Science, AI&DS, and Professor Rasmita Mohanty, as well as Professor Madhuri, for inviting me for this ATAL Faculty Development Program. And the title of this program is Joy of Artificial Intelligence in Action, Applying Traditional and Agentic AI to Real World Problems. And a very good evening to all the participants and welcome to the first session.
It will come.
So in the first session, we are going to discuss about some of the fundamental aspects of artificial intelligence and traditional machine learning. And in the second talk, I will show you the roadmap of traditional to agentic AI.
Now,
Okay, so I hope you are able to see my slide. So during my presentation, if you have any question, you can post your question in the chat box. I will respond it first, then we'll continue with the next topic. So what we are going to discuss in this session, first I'll show you some motivation of going for this artificial intelligence and machine learning domain. Because you know, when we talk about Industry 4.0 and Industry 5.0, AI/ML plays a very important role. Whether it is academia or it is a industry, all these people are heading towards artificial intelligence and machine learning. Not only the branch of computer science, but also other disciplines also, they are now integrating the field of AI/ML into their respective domain. So I'll show you some of the motivations behind people going through this particular technology of artificial intelligence and machine learning. Then I will introduce a formal definition of machine learning. And before going for different type of techniques associated with machine learning, I will show you the difference between rule-based system and machine learning-based system. In fact, these rule-based systems are called as non-machine learning-based system. So before machine learning also, people have addressed many problems. Those were the rule-based system. So given a particular problem, you need to decide whether to go for a machine learning based system or you have to go for a rule based system. That's why you should know that what is the difference between the rule based system and machine learning system. Then we'll discuss about some of the ideas to implement the end-to-end process of machine learning, starting from collection of the data to getting insights from the data. And I'm going to discuss a very important question, that what can machine learning do? It is not like that you go for any type of problem and apply machine learning technique. but it is important to know that whether machine learning is suitable for that particular problem. If it is not suitable, then well-defined approaches are there, like rule-based system, that can solve the problem. If it is suitable for machine learning, then only you can go for the machine learning based system. That's why for every problem you have to examine whether you can solve that using rule-based system or machine learning system. So these are the topics that I am going to cover in the first session, followed by the conclusion and references. And for easy interaction, and I am going to show you some of the videos related to the machine learning, so that you can understand the topic of the machine learning in addition to what I am speaking in this faculty development program. So let us start with a very small video which defines what is machine learning and what is learning. Alternatively, you can access this particular video from YouTube, but I am sharing from my screen, and you can watch this video which defines what is machine and what is learning and what we are going to see in machine learning.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves, but soon we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course, there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. The technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently using less computing power, from medical diagnoses to social media. The potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.co.uk.
So based upon this video, if I ask you that how you are going to define the machine learning, can anybody answer? What you have seen in this video, and based on this video, how you can define the machine learning?
Sir, by images, it will automatically learn edges and everything, and I'd compare the edges with the new image.
Yes. So what sir is saying, I am formalizing that this video shows that initially we did with we have trained a model with 100 photos, and we got some accuracy of, let's say, 55%, and we are not happy with that accuracy. That's why we collected more photos. Let's say we collected another 100 photos. Together we have 200 photos. Then we achieve a let's say accuracy of 78%. Then we gather another 100 photos. Together we have 300 photos. So we got an accuracy of 89%. Similarly, when we add 100 more photos, we got accuracy of 95%. So what it shows that when you model a learning model with very less amount of the data, then it may not perform well. But when you model the same thing with a very large amount of the data, then you can see the model provide you a good accuracy. Another observation you might have done while I showed this video, that this video shows that how to categorize dog and cat. Dog has certain features, cat has certain features. So based upon their features, if I want to separate the dog and cat by taking different type of images, I have trained a model with some dog images. I have trained this model with let's say cat images. Then I am going for unknown images, and I'm asking the machine to predict that whether it is a dog or it is a cat. So that shows that we are not only relying on the data, but also we focus on the patterns that are the hidden patterns behind that particular data. And in the later part of this video, you have seen that it is showing several applications. We talk about our mobile phone. Whenever we type a particular word, it is suggesting various words. That is also application of machine learning. If you go for our email system, automatically some emails are going to spam. That is also an application of machine learning. So in our day-to-day life, whatever applications we are making, behind all these applications, we have a machine learning technique. So if you want to define the machine learning, there are many researchers have given their thought of different way of defining machine learning. Like if I ask a physicians to define a machine learning, if I ask you a computer scientist, if I ask you a mathematicians, then they define the machine learning in different way. Like one of the definition which is given by Herbert, he mentioned that learning is any process by which the system improves the performance from experience. Like whenever you are solving a particular problem, you do not have experience, so it may take a long time, or it may require a lot of calculations to solve this problem. But once you understand the problem, if I give the same problem in later point of time, you have some experience. So based upon your experience, you can improve the performance. So in machine learning, it is a specific field of artificial intelligence. AI is said to be the superset of the machine learning. Machine learning is a very small field under the artificial intelligence, where we are interested to make a system learn to find different kind of patterns in examples in order to make the predictions. We make predictions based upon the data which we have collected and finding the patterns in that particular data. Another interesting definition you can see here, we want to learn our system without explicitly programming that particular system. Because when we go for a computer program, we explicitly program all possible number of cases. Like if I talk about who is eligible for vote, you will say those people who are greater than 18 age, greater than equal to 18 age, they are eligible for vote. And those people are having less than 8. They are not eligible for vote. So what we did, here we did some explicit programming. But when you go for the machine learning system, we don't want to explicitly program a computer for finding something. That is the basic difference between a traditional system as well as the difference between a traditional system and today's machine learning based system. Now, you may have a lot of questions with respect to this. For example, somebody can ask how to find some interesting pattern from the data, how to make predictions, what are the techniques that are behind the machine learning, and so on. So I'll address all these questions one by one. So before addressing these questions, I am showing you one of the popular hype cycle which was released by Gartner. Gartner is a research and development firm. Gartner releases hype cycle twice in a year. I am showing you the latest hype cycle of September 2024. And Gartner releases this hype cycle by taking time in the x-axis and expectation in the y-axis. So these are not only related to AI and ML, but you can see this is a emerging technology. Like in the inauguration session also, Professor T. Kumar mentioned about quantum computing. Okay, this is also one of the technology. Like many people are also talking about the 6G. Many people are also talking about digital twin, a lot of things. But when you see these emerging technologies, like if I go for generative artificial intelligence, or if I go for AI augmented software engineering, or I go for AI Prism, right? Or you go for machine customers, all these maximum fields, like you go for federated learning, reinforcement learning, all these technologies that are present in the emerging technologies. And these technologies, if you see their life period based upon whatever the color it is assigned to these particular technologies, like here you can see generative AI, which is popularly nowadays we call it ChatGPT, is one of the popular, you can say, popular technology. So it will sustain in the market for 2 to 5 years. Similarly, if I go for AI augmented software engineering, its life period is also given as 2 to 5 years. So all these technologies that are present in this emerging technology, more or less they are relying on the artificial intelligence. Similarly, Gartner also releases the hype cycle with respect to a specific technology. Like you can search for hype cycle of artificial intelligence. Those people who are interested in cloud, they can search for hype cycle for cloud computing. Those people who are in quantum, they can search for hype cycle for quantum computing. So this shows that what are the sub areas of artificial intelligence and which area is immersed, which area is yet to be explored. For example, if I go for quantum artificial intelligence, you can see this is marked with a yellow, this is marked with a triangle. And if I see here, show you here, this triangle indicates that this technology will sustain in the market for more than 10 years. Similarly, if you go for AI engineering, generative AI, edge AI, AI Tritium, composite AI, neurosymbolic AI, so more or less all these technologies are sustained in the market for 2 to 10 years. So what this hype cycle suggests that if we are interested in this particular domain, we can explore these subfields which we need to be explored, and we can develop some kind of products which can be accepted by the industry. Because this hype cycle is not only famous in academia, but also this is widely accepted by the industries. Because this hype cycle is generated by taking interviews of various chief executive officers, chief technical officers, many software engineers. Based upon that, this hype cycle is generated. Of course, this hype cycle is generated twice in a year. You may not get the latest hype cycle in the public domain. That's why I'm showing you the latest hype cycle that are available in public domain, which is of June 2024. Now, you may heard different terms related to the artificial intelligence, which I am showing you here. Like nowadays, people say about explainable AI, interpretable AI, generative AI, large language model. But basically, these technologies are differ from each other. So you need to understand that what is the basic difference between all these technologies. Like when you go for explainable AI, I'll take an example. Like a person visited a particular bank with an application of applying loan, and the cashier or the manager has entered some basic details about that particular person in a computer, and the computer shows a message that loan is rejected. So when the loan is rejected, the user is not happy, user shows his dissatisfaction, and user wants to know that why that loan is rejected, what may be the reason behind the rejection of the loan. So explainable AI helps humans to understand why an AI makes the decision. Let's say this computer system is having an AI model based upon the historical data, and based upon the historical data, it will make a decision that whether to accept this particular loan or whether to reject this loan. And this AI model is rejecting the loan. But this AI model, if it explains why the loan is rejected, this comes under the explainable AI. For example, I can say that loan is rejected due to you are not in the locality in this particular location for let's say more than 1 year. That is the reason why loan is rejected. Or I can say your income is not greater than some limit. That's why your loan is rejected. Or I can say credit score is not good. That is the reason why loan is rejected. So that is the basic idea of going for this explainable artificial intelligence. Now, coming to another technology which are very close to interpretable AI, another technology that is interpretable AI. Interpretable AI is inherently understandable. Although this model, this focuses on the output, right? whether a loan is rejected or accepted. Whereas interpretable AI is depending on what is the internal details of a particular model. For example, it says that if income is greater than 70,000 and credit score is greater than 600, then the loan can be approved. If this condition is not satisfied, then the loan is going to be rejected. But here, when the loan is rejected, it is showing what is the reason. For example, it's saying that your income is, let's say, 50,000. That is the reason why it is rejected. And let's say your civil score is 500. That is the reason why it is rejected. So it focuses on the outcome, right? Why loan is rejected? Because of this reason. But if you look into the internal structure, you will find that what are the conditions associated with a loan rejection or loan acceptance. So that is considered as an interpretable AI. Similarly, nowadays, generative AI is very popular. Like ChatGPT is very popular nowadays, right? If you want to write a program, you simply go to ChatGPT and write the question, and ChatGPT is generating that particular program. Okay. But how much correct that program, that is different thing. How reliable that response, that is different thing. But we are able to generate some kind of text. So generative AI is focusing on generating some kind of text, images. Like if I ask you to summarize a particular report within a single picture, that also ChatGPT can do, right? So when you look into generating different content, then generative AI plays a very important role. And in fact, nowadays very popular models are available, like ChatGPT is a model, is a platform, or I can say Gemini is another platform which supports the generative AI technology. Now there is another technology, another model it is coming, which is based upon the very large deep learning model, which we call as a large language model. Okay, in fact, generative AI generate these text and images based upon the large language model. So LLM is an artificial intelligence that understands the language. Okay, LLM, it is nothing but a deep learning model. Like you know about many deep learning models. So similarly, LLM is also different, having a deep learning model, but it is a very large deep learning model that understands different languages. For example, if I ask explain the water cycle to the chat GPT, so behind that the model that is used is called as large language model, which is generating different type of text. So I can say generative AI is a overall platform, but inside that we have different large language model. So this way, these technologies are differ from each other. Now, if you see the trend of artificial intelligence in machine learning with Google perspective, like if I want to know whether people have interest in searching this keyword artificial intelligence and machine learning in a, let's say, worldwide context, and I want to know from 2004 to till date. Right, this is the maximum period where you can find how many search queries are generated by Google, right? Or how many people are searching this particular keyword, artificial intelligence and machine learning. So if you see here, artificial intelligence is showing the blue color and machine learning is showing in the red color. So you can see gradually the artificial intelligence is not that much popular, right? But you can see machine learning is increasing, and this trend is more or less it is below 50. If I see the relative index, it is below 50 for both artificial intelligence and machine learning. But after you can see around 2016 and 17, there is an increase in the number of search queries related to artificial intelligence and machine learning. Similarly, if you want to know that which country generates most of the search query related to machine learning, you can, or artificial intelligence, you can see Philippines, Tanzania, Oman, Nigeria, and Uganda. These are the 5 best countries in the search query, and India is also very close to their index, right? But it is not coming in the top 5 search query in terms of searching the keyword artificial intelligence and machine learning. So this thing you can get in Google Trend, right? If you go to the Google Trend, you can get these statistics. Similarly, you can also find what are the related questions people pose with respect to artificial intelligence and machine learning. Like people usually put a data science and artificial intelligence, which is related to AI/ML, People also have searching how blockchain can be integrated in AI and ML, artificial intelligence applications, big data, what is machine learning. These are the different questions people put in the open forum. Similarly, with respect to machine learning, I am getting deep learning, machine learning in Python, machine learning for engineers, GitHub, Python for machine learning. These are different type of questionnaires. Similarly, if I look into the Indian context, okay, you can see the peak is already arrived in the year of 2004. Okay, at this particular period, maximum search query is generated for artificial intelligence, right? Then you can see it is gradually reducing, or it is, I can say, it is close to the relative index of 50. But worldwide context, it is increasing. But in Indian context, it is now considered is a in average keyword. The reason is that nowadays people are focusing on hybrid model rather than going for the base model. That is the reason why the maximum search queries are not generated with respect to the keyword artificial intelligence and machine learning. Similarly, in Indian context, you can see these are the states where maximum search query is generated. One is Mizoram, followed by Nagaland, Chandigarh, Jammu Kashmir, and Andaman Nicobar Island. So where maximum search query is generated. Now, if you see the applications of machine learning, one of the applications I'll discuss here, which is called as Quick Draw. So you can go to Quick Draw in your web browser. I will share the link in the chat box. You can just open so that you can play this particular game also. And behind this, we have the machine learning. So I shared the link in the chat box. Once you go through that particular link, so if I show you here, this is the URL. If you visit, then you will get here. What this game says that? This game says that you have to draw something within 20 seconds. And whatever you draw, based upon that, it is trying to recognize different objects. Okay, for example, if I click let's draw, it is asking me to draw a cat within 20 seconds. So whatever I write, based upon that, it is going to tell whether it is a cat or not. For example, if I take a circle,
I see circle.
Then it is saying it is a circle, or it is a moon, right? So suppose if I am connecting something,
I see comet.
And I can say let's say some legs kind
or
of
table.
So it is saying it is
or
a
head.
table. So
I see
within,
yogurt.
so within
or ring.
20 seconds, you have
or
to
mosquito.
draw a
Sorry,
cat.
I couldn't
Right.
guess it.
So within 20 seconds, you have to draw a picture. Now, question arises that whenever I have drawn a circle, or I have made some leg by putting some straight lines, how this particular game identify this is in circle, this is in this 4 means it may be related to the table, or it may be different lines, that you should know, right? So behind that, different examples are there, right? So these are some basic questions people usually post, right? How does this game work? Okay, behind this game, some examples are there. Based upon that only this game is working. And how is it recognizing your drawing? Not only it is capturing that whether it is a cat or not, or dog or not, but it is checking that whatever you are drawing, based upon that it is going to recognize. And the last question which it can ask, that how could we program this particular game? These are some fundamental questions that we are going to discuss before we go for different machine learning based applications. So in order to understand this, I am sharing another link in the chat box. All of you go through this link, or the same URL you can use, and you can put /data. Okay, same one you can use, and you can put data. So let me go to that link now. If I go to this link and if I type data, then you can see the data behind this quick draw. Right? For example, here you can see it is written, what do 50 million drawings look like? Right? So you can see there are several drawings here, and these drawings are not artificial. It is not generated by generative AI. It is really drawn by different people like us. Okay, that's why they prepared this particular data set by collecting different images from different people. For example, if I want to go for airplane, okay, or aeroplane, so it is showing that for aeroplane you are looking 1,35,821 aeroplane drawings made by real people on the internet. It is not generated one. Okay, it is done by different people. And if you found that, let's say I found that let's say this is not an aeroplane. So what I can do, I can simply click this one, and I can click flag as inappropriate. So they are going to review this particular image. If they feel correct, then they will remove or they will keep as it is. So behind any type of objects, right, whether it is a cat or it is a dog or you can say it is a apple, so there are many drawings that are drawn by the different people. Okay, so what I try to convince you here that these are different drawings, but behind these drawings, what you have different patterns. Pattern helps us to identify whether a particular object, belongs to let's say cat, or whether a particular animal related to cat or related to the dog. So that can be identified by looking into different type patterns. Like here we are showing a lot of patterns. Okay, lot of images from there. Pattern is generated. When you draw a particular image, it is going to check that. Now, if I ask you here, how does machine learning work in quick draw? So you have seen there is a very large amount of data. Like I told you, 1 lakh plus images. It's a very large amount of data. That is actually used to teach this game how to recognize these images. For each and every object or an animal, you have a lot of images or lot of data that is going to recognize whether it is belongs to that particular object or animal or not. But there is an interesting thing you can see. Suppose you can see in the quick draw data there is a object called as carrot. When I ask you to draw the carrot, so somebody can draw the carrot like this, right? Let's say somebody will draw like this, right? Okay, suppose I am putting some power kind of thing here. So you will say this is a carrot. Now, somebody has not seen carrot. How you are going to explain? You can explain through an image, like I have drawn a triangle and I put some flower kind of thing, and I convince that person that this is a carrot. But it may happen that some carrot look like rectangle shape rather than, let's say it is in rectangular shape, and this is also a carrot. But when I have represented the first image, I treat it as a triangle. It is not a rectangle. When I go for the second one, I treat that as a rectangle. So when you are going for a machine learning based system, you have to ensure that all the carrots should not be of triangle type or rectangle type. If you do so, then when you show a carrot with other type of shape, it is not going to recognize it. That is a major issue you are going to get when you go for a machine learning model. That's why in that video also, if you remember, I told you when we go for learning a particular model with 100 photos, then it is showing only 55% is the accuracy. When I go for 200, then 78% is the accuracy. When I increase it to let's say 1000, I am getting 99% accuracy. So it depends upon what are the different type of shapes that you have captured through this particular images. Now, before going for a rule-based machine learning-based system, you should know which problem can be solved in a rule-based system. Like given a particular problem, I need to identify whether it can be solved using a rule-based system or it can be solved using a machine learning system. So what is a rule-based system? The rule-based system or a machine learning system comprises of 3 steps. So in rule-based system, first you have to frame the goal of the product. You have to frame the goal of the product. You need to decide what is your goal, what you want to achieve. For example, I have let's say 3 objects. One is object X, another is object Y, another is object Z. So my goal is to identify the object X or Y or Z, right? Now, in order to identify whether a particular object is matching with the properties of X or Y or Z, the designer and engineers develop different kind of flow and logic. Like for example here, for object X, okay, for object X, I have some kind of rules here, like object dot height is greater than 10. If object dot height is greater than 10, then I recognize that as object X. Similarly, if object dot color is blue, I recognize it with Y. Similarly, object dot number of legs is greater than 2, then it is considered a Z. So this is the flow and logic to recognize X and Y and Z. For example, you are not happy with this logic. So what you have to do? You have to again refine your flow and logic. You refine your flow and logic in such a manner that you can get what you are expecting. Like until unless your goal is satisfied, you are going to modify it. For example, here I will also write object dot height is not only greater than 10, but also the color should be black. Then only it is recognized as X. So like that, the designer and engineers develop different kind of logic to meet the expectation of a particular user. It is not possible in the very first iteration to get the accuracy of 100% or 99%. So it needs to refine several times in order to meet with the goal. But when I go for a machine learning system, it is also a three-step process. Here also you need to frame the goal of the product. But after framing the goal of the product, for example, my goal here is to identify whether an object is a carrot or not. Okay, whether it is a carrot or not. So for this, what I have done here, I have trained a model with several examples. Like here you can see, I have taken 10 different images of carrot and I developed a pattern. Right? These are nothing but the examples through which I am convincing my system, like or a machine, that a carrot looks like this one. Then using these 10 different images, a carrot pattern is generated by the image, right? And this is considered as a reference point. Using this reference point, if I go for the 11th image, these are 10 images. If I go for 11th images for testing whether it is recognizing it as carrot or not, right? Then if I take 11th image here, right, 11th image here to compare with this particular pattern, if it is matches, then I can say it is a carrot. If it is not matching, then I can consider that it is not a carrot. But there may be a false positive cases also. Sometimes there is a carrot, but I am recognizing it is not a carrot. So I need to refine the things until my goal is satisfied. So both case, the first and third step is same, and it is not possible for any system to get good accuracy within a first couple of iterations. But when you do a several iteration, we meet the expectations. So in the previous case, the designer write the logic by explicitly programming. But when you go for machine learning system, I don't want to go for explicit programming. Rather than I am going to train the model, okay, with examples and test the model. Based upon that, I am going to calculate the performance of the system. So there is no need of any explicit programming. This way, we can distinguish between the rule-based system and a machine learning-based system. So what I can say here, machine learning is an alternative approach to building software. Nowadays, whenever we are developing a software also, we are not starting from the scratch. What we do, we have taken some thing which is already exists. Based upon that, we are generating the new code, right? For example, as I said, you can type in ChatGPT about a particular program, but when you run this program, let's say the program is not successful. So you check the code of the program and you rectify that error. So you are not building a model from the scratch, right? So in this case, instead of programmer is creating a rules, a model is trained with examples. If you have sufficient data, if you can train a particular model, then you can go for machine learning based system. But if you want to go for different kind of rules which need to be programmed explicitly, then you can go for the rule based system. So there are several limitations you can find. Like I already told you, one of the limitation is that if the examples are of similar type, like when I move from 100 photos to the 200 photos, initially I trained a model with 100 photos, then I want to take 200 photos. So I have to ensure that the the extra 100 photos should be of different type. It is not like that I'll take these 100 photos, I'll copy these 100 photos and make another 100 photos. That is not the correct way. That's why it says that machine learning model is only as good as the example. It is as good as example, right? If you take different images, then only the performance can be increased. But if you take similar type of images, then the model will not perform well. One an example which I already told you, that if I take let's say all the examples of triangle shape for a carrot. In case of carrot, if I take all the images of triangle shape, so if I show a carrot with rectangular shape or other than this triangular shape, then your machine is not going to recognize it is in carrot. That's why more examples of variety of type if you collect, then that can be suitable for machine learning based approach. So now you may ask, what type of task do you think would be a good fit for machine learning? So obviously, the task which is good for machine learning is that it should have sufficient number of examples, as large as examples, right? As big number as examples. Second one, you will be able to generate the pattern from that particular examples, because using that pattern, you will compare with your testing model. Whenever you go for the test a particular model, you will compare that image with your pattern. If it is matching, then you will say yes, it is identified as the subject. Otherwise, you will decline that. So machine learning is as good as example. If you do not have sufficient examples, it is better to go for a rule-based system rather than a machine learning-based system. Now I'll show you several examples, and you can suggest me whether we can go for a rule-based system or we can go for a machine learning-based system. For example, I have a set of songs. Assume that I have a set of songs. I want to order these songs in the alphabetical order. Whether I have to go for a rule-based system or a machine learning-based system. You can type in the chat box. If it is a rule-based system, you type 1. If it is a machine learning system, you can type 2. If you have a set of songs or a list of songs, you want to order them in an alphabetical order. So try to understand this problem. Understanding the problem and the viewpoint of the problem is different, right? Okay. You can some people, most of the people have written 1, so they are saying that rule-based system. But we need to think about that why it is a rule-based system. Now, if I go for alphabets, so if I am talking about the English language, all of you know we have a fixed number of alphabets, right? Like capital A to capital J, or if it is a small letter, small a to small j. And if I go for a if-then clause, if it is a capital A or small a, then it should be put under A. If it is a capital B or small b, it can be put under small b, right? If I do so, so there are many sorting algorithms we have seen. Sorting algorithm is nothing but ordering them in one particular order. Whether it is a increasing order or decreasing order, in some order we have to do. So as there are sufficient number of sorting algorithms are there, or well-defined algorithms are there, so this is very easy task. And number of alphabets are also not much, right? If you deal with only 50 alphabets, okay, or 52 alphabets, small letter and capital letter, so it is not bigger, right? So it is possible to solve this problem in a rule-based system. But if I tell you that number of alphabets is a very large number, okay, and I'll tell that sometimes you have to correct the first word, because we are sorting based upon the first word of a particular song. Okay, and let's say the first word of the song may be misspelled. Okay, in that context, you need some kind of intelligence, right? You need some kind of your model should understand that the word which is entered as the first letter of first word of a particular song, which may or may not correct. So in that case, we can go for a machine learning based system. So it is a rule based system in the thought that it is a very well defined task. We can sort using the algorithm. On that basis, I am saying it is a rule based system. Now, if I ask you the second one, I want to rank the web search result. For example, I want to search about this faculty development program. I'll type in Google AICT ATAL FDP on, let's say, artificial intelligence or joy of artificial intelligence, right? Then, whether it is a whatever the web pages that are going to come, whether it is based upon the rule-based system or machine learning system. What is your answer? You can write 1 for rule-based system, 2 for machine learning-based system. Again, you may have different viewpoint also. Like I am searching about this FDP, right? I am searching about this FDP in a Google tab, right? So when I search for this FDP with some name, FDP with some name. So let's say each and every web page, okay, is having a counter. Each and every FDP is having a counter. So when there is a hit, okay, because it is showing different type of web links. Suppose a user click this web link, then its count value is going to be increased to 1. Earlier it is 0, now it is going to 1. If another user choose this one, right, then let's say this counter is increased to 0 to 1. Like this way, if I maintain each and every web page count, then we can apply a rule-based system. Simply I'll attach a counter and based upon that I can do this one. But if I ask whatever keywords I have given here, it should be more relevant to the content of the web page. Okay, it is more relevant that content of the page. It is more relevant to which one is a recent one. It is more relevant to how many people visited that site. When I put a lot of constraint, then I can go for a machine learning based system. So all problems can be viewed as a rule based system. It can also be viewed as a machine learning system. So that's why here we ask one important question. Are you ranking this web result based on the relevance to my query? If you talk about the relevance, then you go for machine learning system. When you go for a counter kind of thing, you can go for a rule-based system. For example, if the query is about a particular news, so you might also want to take into account how recently the article was posted and how my query is related to the recent article, recent news. On that basis, if you go for this particular problem, then it is considered as a machine learning based system. Now, if I ask you predicting the housing prices based on location, suppose you are residing in Hyderabad, right? And I want, let's say Hyderabad is having a location called as Gachibowli, right? And I want to know what is the house price of Gachibowli location. Whether I want a rule-based system or I want a machine learning-based system. Can anybody answer in the chat box? 1 for the rule-based system, 2 for the machine learning-based system. Predicting housing prices based on location. Now you forget about these big locations or metro cities. Now in your area, right? In your area, there may be different 2 BHKs, 3 BHKs nowadays we are saying, right? So if you want to rent a 2 BHK, so is there an uniform rate you are following with respect to different colonies or different streets or different cities? The answer is no. That means there is no perfect formula you can apply to calculate the housing price of a particular location, because it depends upon the type of house also, right? If the house is having so many amenities, so many interiors, okay, so in that case the price will increase. If the house is a normal house, okay, a newly constructed house without having anything, the price will be less, right? So whatever may be the factor, whether it is a new house or it is having a lot of amenities, but it is not possible for us to predict the price. And even if there are 2 houses in the same flat, they may charge differently also, right? So as there are various factors are associated with this one, I can say it is a rule-based, it is a machine learning-based system. But if somebody will say that no, we are going to follow a uniform price, Like if you talk about government quarters, right? So based upon the type of quarter, there is a uniform price is applied. Then in that case, I can say rule-based system. But that is a very, you can say, very simple case, right? But when you go for a in general case, it is a typical case, I can say. But when you go for a in general case, you need to consider various factors. Based upon that, you can say what is the price. That's why machine learning system is more suitable. Now, processing the online payment. Every day you are paying some amount through UPI, right? If I consider UPI as an online payment, right? So whether it is a processing of this payment is a rule-based system or it is a machine learning-based system. What is your answer? First one is rule-based system. Now let us consider this process. Like when you go for an UPI, let's say Google Pay, Phone Pay, or you can say any application you are using, VMAP, and many applications we have, right? So we open our app, right? Then we scan a QR code, right? Then the details is fetched to our mobile through internet, right? Then we enter some amount, then we enter some MPIN, okay, mobile PIN or some code. Based upon that, the payment is successful. Now you tell me, in each and every step, it's a very straightforward process. Each and every step, we are having a very straightforward process, right? So you can program it step by step. One step is completed, then I'll go for the second step. Second step completed, I'll go for third step. Okay, so this can be considered as a rule-based system. But if I say that in the processing of online payment, you need to detect the fraud, whether somebody is doing the fraud or not. Like you always make a transaction less than 10,000 rupees, but suddenly somebody is trying a transaction of let's say 90,000 because our UPI limit is let's say 1 lakh. So in that case, you need to identify the fraud. So there you can think the processing of online payment is a machine learning based system. With identifying the fraud, it requires a deeper analysis. So there we can go for machine learning system. But if you go for processing online payment in general, it is considered as a rule-based system. Similarly, when you go for classifying an object in a photo, like there is a photo, I want to classify a particular object. Now, if I take multiple photos, you can say if multiple photos the same object is there, then these two images may slightly differ also. Right? Sometimes the background people are moving. Sometimes you can see. Yeah, any question, anyone? Okay. So if I'm taking a multiple images, I can say the quality of images are different, lighting conditions are different, angles are different, and background peoples are different. So identifying that particular object in various photos, okay, it is quite challenging. So in that case, it needs several type of variables. So I can go for a machine learning based system because there is too many variables to try and create rules for every situation, and you cannot make a lot of rules for classifying the object. If you write also, it is very difficult, right? But when you use a machine learning system, it is very easy to build such system, or because it is going to identify that object in various images by considering various factors based upon the model. So in this case, machine learning is more suitable compared to a rule-based system. Now, to summarize the comparison between the rule-based system and a machine learning system, what we have seen in rule-based system, rules are defined. You need to define each and every rule, so it should be explicitly programmed. But when you go for machine learning system, we learn the different kind of patterns. So there is no predefined rules. You should not write all the possible conditions. So I can improve a rule-based system if the designer and the programmer will focus more on algorithm and network. But in machine learning case, I can improve a particular model when I collect additional data, not the existing data, additional data, right? Whatever data you have used to generate a particular model performance, you need more data, then only the performance can be improved. So whether it is a rule-based system or it is a machine learning system, one cannot replace other. So it is not possible that machine learning is going to replace a rule-based system, or rule-based system is going to replace the machine learning system. Rather than we can say each and everything has different benefits. Now, Google uses various type of products, like you know about YouTube, you know about Google Translate, Google Assistant, then Google Translate, Google Map, our Gmail, and Google Cloud. All these famous Google products are uses machine learning in the behind the screen, right? They use machine learning system to predict this thing. Now we are going to see what is the idea to implement a particular machine learning system. So in order to understand that what is the idea, we can say you have to rely on an end-to-end process. So what is an end-to-end process? So broadly this end-to-end process is divided into 5 parts. First, you need to frame a problem statement. Okay, for every type of, like whether it is a credit card for detection, or you talk about email is inbox, email is going to inbox or spam. All these cases there is a problem statement, and these problem statements are generated by focusing on the user. So once you identify the user, right, then only you can able to find that what is the problem statement. For example, here you can see I am focusing on the user because user face this fraud, user face this email is going to inbox or email, so many emails are flooded into the inbox, so many junk emails are coming. So I need to focus primarily on users, right? So ML begins with the need of a particular user, need of different business. Based upon that, I will focus on different users. Now, the second step is that I need to define what is the objective. Our objective is to find the fraud. Our objective is to classify an email, incoming email, into inbox or spam. Right? So I need to define what is the objective. For example, your objective may be when you are visiting a particular city for the second time. For example, you are visiting Hyderabad for the second time. Whenever you came for the first time, you took biryani in some place, right? So whenever you are visiting the same city again, then it is suggesting that last time you took this biryani in this particular restaurant, and you gave 5 out of 5 rating. So this is also objective. That is nothing but recommending different restaurants or recommending different foods to a particular customer, right? So this way we can define what is our objective. The third process is we have to collect the data. Not only we are going to predict, or we can say that the user is last time took the dinner here, but also we need to collect the data how to improve our suggestions. Right? That's why many experts says that you need to collect the data, clean the data, exploring the data, and other related data related processes are the longest time in the machine learning process. Data itself is more important. If you are getting a pure data, half of your work is done in the machine learning. But whenever you are collecting the data from various sources, sometimes we are not getting the cleaning data. The data is not clean. The data is having some abnormality. Data is having some outlier. Data is having some missing values. So all these things need to be explored in order to apply the different machine learning approaches. You cannot apply machine learning approaches without the data pre-processing phase. If you do so, whatever predictions you will make, that is not a correct predictions. So machine learning models learn from examples. That's why you have to ensure that a very large amount of data is collected and they should be in a similar form. One of the example I can take you here, like date of birth. If I ask you to write the date of birth, some people can write in DD, date followed by month followed by year. Some people can write month followed by date followed by year. Some people can write year followed by month followed by date. So when we collect the data from various sources, if the data is not present in an appropriate form, then it is quite challenging for us. We cannot rely on that particular data which is not represented in a proper form. Now the fourth step that we are going to do is called as the process of training and testing. Okay. So broadly, whatever data you have collected, that data only we have to split into training and we have to split into testing. Like as a teacher, most of you are teachers. So when you are teaching to your student around, let's say 30 to 35 to 40 classes per subject, then whatever you have discussed in the class or assignments, this is considered as the collected data. And whatever teaching learning process you have given, that is called as training. And once the training is done, then you took different kind of exams, like mid-break exams or end exams or some quiz test, surprise test, and so on. These are considered the testing. So the process of training and testing is going to be done based upon the data. Now the fifth step is called as predict and evaluate. Once the process of training testing happens and you are happy with training accuracy, you are happy with testing accuracy, the next process you have to apply is called as predict. You have to predict the future outcome. And if it is not proper, how you are going to know that whether the prediction is correct or not? Based on some evaluation measure. And if you are not happy with the evaluation measure, like I have collected, let's say 100 photos, I am classifying the object, I found that the accuracy is 55% and I am not happy with that 55%. Then what I have to do? I have to again come to the collection of the data. Then again do the process of training testing. Then again do the prediction and evaluations. So this process I have to reiterate for multiple times. If I do so multiple times, then you can see in every iterations you are improving a lot. Right? You are improving. So if you go for more number of iterations, that your performance can be improved. Another way you can say that whether it is meeting the goal of this particular user or not, that is more important. Sometimes we are deviating from the goal, right? So if it is so, you are again going to define that particular goal, because user may not have a clarity when the user has solved a particular problem. But over a period of time, user understand that this problem is having this much complexity. That's why in that case, we need to focus on user. We need to define our goal, or we need to define our goal to improve, to identify what is our focus, what we want to achieve. That can be determined by looking into this. So one of the software engineer of Google Translate mentioned, which I already told you in another form, he mentioned that sometimes you have 10,000 training examples, your system is not working. You have developed a model, the model is not properly working. Now you increase the training examples from 10,000 to 10 million. Initially you tried with 10,000 training examples, it is not working. Now you increase 10,000 to 10 billion. 10 billion is a very large number. So you will see if these 10 billion training examples are different examples, then your machine learning model starts working. That's why we say data trumps everything. Data is everything when we go for the machine learning based model. Now, although we say about a different machine learning model faces so many issues related to the bias. Mostly, this bias is categorized into three parts. One is called as interaction bias, latent bias, and selection bias. So for this, I am showing you a small video, because this video will help you to understand what is bias. Then we will discuss again. So let us watch one more video.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men, and selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool in the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation, because technology should work for everyone.
Okay, you have seen that there are different type of biases which is shown in this video. We'll discuss a little bit about this one. So as I mentioned that there are three different biases you can see. One is called as interaction bias, latent bias, and selection bias. Like as a human being also, sometimes we say this one is biased, right? Suppose you are asking opinion to your friend, one of your best friend has suggested something and you are readily accepting this, then we can say you have not taken any decision, you are relying on your friend's decision, so you are biased. So there are different type of biases you can see. I'll show you a picture here which will give you a little bit clarity. Like I am showing you three different persons, right? Like first person is having let's say a running nose. The first person is having running nose. Second person is having running nose with let's say cough. Third person is having running nose plus let's say cough plus having fever. So now which one I'll consider as common cold, which one I'll consider as a flu. So that shows a example of a bias. For example, in this video also you have seen that I am suppose imagining a shoe, right? If I am imagining a shoe, so those people are let's say male, their gender is male, they may look the shoe in a different way. Those people who are female, they can look their shoe in a different way. So this create one type of bias that is called as interaction bias. So interaction bias occurs when the system's output is influenced by how a user is interacted with it by creating different feedback loops, right? So obviously I am not going to visualize all type of shoes. Some shoes only I am going to visualize. I am not going to look into different type of shoes. That kind of biases are called as interaction bias. Second bias is called as latent bias. So latent bias generates or originates from cultural, social, or historical patterns, right? For example, if I say cricket, then some people may think about Indian cricket team. Those people who are aligned with the women cricket team, they may also focus on women cricket team, right? So based upon that different cultural difference, social difference, historical pattern, you are going to imagine a particular cricket team. That kind of bias is called as latent bias. Third type of bias is called a selection bias, right? Suppose if you go for a medical artificial intelligence and it is trained only on the patient data from urban hospitals. So that is called as a selection bias, because when you apply the same thing for rural area, the system performs poorly because you focused only the data which are related to the urban. Because some diseases may be common in urban, but there may be different kind of diseases you can find in the rural. So as a human being, you may have also bias in some time, right? Based upon the opinion of your friend. Similarly, machine learning also machine learning also faces this problem of different kind of biases, right? Now, another interesting part in machine learning is that machine learning privacy, because all these data which are associated with the human being, right? Whether you want to design a artificial intelligence system for medical domain, or you want to do in agriculture domain, or any applications. Finally, you are gathering different kind of data, and you are applying different machine learning model. And privacy ensures you that you should not reveal any private information to others, right? Obviously, somebody can say that I have very less amount of data. For example, if somebody is having 2 GB of data, It is more secure compared to somebody is having 20 GB of data. Somebody is having 20 GB of data is more secure compared to 2 TB of data, right? So obviously, if you have very less data, you have less things to protect, right? But apart from this one, what how much data we have, but various laws and companies and company policies also regulate how we are going to keep the data as private. Like some recent incident happened with respect to the Facebook, right? So many people are saying that Facebook, whatever we are posting, that is not secure, okay, or that is not private, right? So there are many laws, regulations, legislations are also imposed by different organizations and governments to make everyone, those who are using this, dealing specially with the data, to make this data more secure. Now, what can machine learning do? So, as I already told you, machine learning can do a thing if you have a large amount of data. If you have very small amount of the data, if you say that I cannot accumulate more data in my particular domain, especially those people who are working in the medical domain, they are suffering with data. Until unless you have some kind of collaboration, nobody is going to provide you the data. You are normally using the data which is available in the public domain, and number of samples in that particular data is very, very small. So machine learning cannot do if you have lack of data. That's why whenever you are applying the machine learning model into a particular domain, you have to ensure that you are applying into that domain and you have sufficient amount of data. So if you compare different kind of models in the artificial intelligence or machine learning and deep learning, you can see AI is a very large area. Inside artificial intelligence, we have machine learning, and inside machine learning, we have deep learning. And this LLM is also considered as a deep learning based model. So LLM can be considered as a subset of the deep learning model. Now, if you want to deal with machine learning, if you want to make your work inclined with the machine learning, so you should rely on some other technologies also. Like as you are dealing with a very large amount of data, how you are going to manage the data? How you are looking a particular data, whether the data is available in a structured form, like a Microsoft Excel file, or the data is available in a semi-structured form, like a XML or HTML file, or your data is available in a completely unstructured form, that you have to determine. So when we talk about different forms of the data and different types of the data, volume of the data, veracity of the data, and other velocity of the data, we rely on the big data. So big data is an integral part of machine learning. Similarly, as you have seen that the algorithm plays a very important role. Machine learning has several algorithms. Deep learning also having several algorithms. So one algorithm may be efficient for one kind of data. Let's say the data is numeric. So I can say this model is best. But when the data is, let's say, in the form of categorical, so other algorithms may perform better. That's why development of algorithms also plays a very important role when we look into the machine learning. And periodically, many other technologies are also associated with the machine learning. Like I told you, quantum machine learning nowadays people are talking, cloud machine learning people are talking. So various technologies can be integrated into the machine learning. So machine learning can be thought by integrating various other technologies along with the big data and algorithms. Now, when you go for the machine learning based system, broadly the machine learning based systems are divided into two types. One is called a supervised learning technique, another is called as unsupervised learning technique. So what is supervised learning technique? Supervised learning technique means if your data is level, then you can say that it is a supervised, you can apply supervised learning technique. For example, I can show you here. I am showing you different images of apple, and I am providing you a annotations by stating that these are nothing but apples. So your not only this model is getting this input data, but also model is getting a annotation. This annotation is also called as level. So when your model is trained, I am showing the model another apple, and I am asking what is the annotation or what is the level. The model says that it is an apple. So this case is considered as a supervised learning technique. But in many cases, you can see you are given with only input data, but you do not have any annotation. Like this is the input data, but I do not have any annotation. So in this case, what you have to do? You have to check the color. You have to check the general properties, like color is a general properties. I can say shape is a general properties. Cost is also one of the general properties. Based upon that, I am segregating different type of images. Like I do not know which one is apple, which one is banana, which one is grape, which one is guava. I do not know. So what I'll tell? I'll tell that these images are looks similar. I do not have any annotation, right? That's why I'm saying that these four images look similar. So they belongs to one of the category, right? Similarly, I found that these two look similar. So they belongs to another category. Similarly, I will say that these images are looks similar. So they belongs to another category. So without annotations also, we are able to categorize different kind of data. That is called as our unsupervised learning technique. So what comes under the supervised learning technique? Supervised learning techniques can be further be divided into two other techniques. One is called as a regression technique, another is called as classification. So you can see regression is nothing but you have to fit the data with some kind of curve, some kind of line. Like you can see, these are nothing but the different data points, and I am fitting this with a particular line. In that case, when I relate the dependent variable with independent variable, I can go for the process of regression. On the other hand, when you are going to classify a particular thing into multiple levels, that is called as classification. Like I have given a particular image, my algorithm classify whether it is a dog or it is a cat. So that is an example of classification. But when I draw when I put different kind of objects and draw a particular line, then that is called an example of a regression. So regression analysis is a statistical method that helps us to analyze and understand the relationship between two or more variables. So when you deal with only two variables, they are called as linear regression. When you deal with more than two variables, we call that as a multiple regression. Like that, you can find there are different regression techniques that are available under this regression, under the supervised learning technique. Now, if you see applications, like if I talk about Google Map, for example, I am finding different routes from Hyderabad to Mumbai. I want to find a different route from Hyderabad to Mumbai. So obviously, the straight line distance from Hyderabad to Mumbai is the shortest distance, and you can find there are different routes. Like this is a route to reach to Mumbai. Similarly, I can find another route to reach like this. But the straight line one is nothing but the closest one that fit with all the lines. So this is an example of a regression. Like here also you can see I have taken different type of objects, but I draw a line that closely fit with all these objects. That actually we do in the process of regression. But in classification, what we are doing, we are having different class level because it is a supervised learning. Like inbox is a class, spam is a class. So whenever I am receiving an email, the classifier identifies certain thing, and based upon that, it is putting it in either in the inbox or in the spam folder, or based upon the, let's say, different features. So if I say that whether your eye color is black or eye color is blue or it is gray, something like that. In that case also, I am going for classification based technique. Or if I go for an animal, right? The animal, like if I am showing a lion, lion is a wildlife animal, it is also a mammal, right? So not only I am going to classify, I draw a particular boundary here, you can see, and I am saying those samples which are above, they belong to another category. Those who are belongs to this particular one, they belong to other category. Like I can say these cases are considered as a cancerous case, these are considered as a non-cancerous case when I deal with a medical data. So this is an application of a classification. So whether it is a classification or it is a, all these are coming under the supervised learning technique. Now, when you go for unsupervised learning technique, as I mentioned, you do not have any class level. Like you are reading a subject which you have never read. In your entire career, you have not gone through a particular topic, but now you are reading that topic and teaching to your student. So what you are doing? You are doing self-study. Or students are given with some course which is self-study course. In that case, student has to learn the thing by own. In that case, some general properties will work, right? Like I mentioned, shape, color. So in that case, you will deal with the on-level data. Now, if I go for different type of technique, clustering is considered as one of the popular technique under the unsupervised learning. Clustering means if I, like in this faculty development program, we have more than 200 participants. Suppose I want to give some assignment. I have to give 2 assignments. So what I did, I have divided these 200 participants into, let's say, 2 groups. Maybe equal group, maybe unequal group, and I have given this assignment and I asked the participant to submit this assignment. Okay, this is considered as clustering. How I am going to divide these 200 people into 2 different groups? That is an example of a clustering. Similarly, there is another technique that is called as association. Association is nothing but who is related to whom. Like when you go for market basket analysis, association plays a very important role. Like whenever you go for a shopping mall, you can find that bread, jam, butter, egg, all these things are placed nearby. The reason is that these things are having some associations. Okay, like here you can see, like by looking into different transactional data, I found that these mobile phones and let's say earphone or let's say router or cable, these are related to each other. So association is considered as our unsupervised learning technique that actually find the important relationship between variable and features in the data set. Like who is related to whom, like whether mobile is related to a screen cover or mobile is related to different kind of accessories. All these things can be done through this association process. So clustering I already mentioned, right? It is nothing but a grouping of different data points or different people into different cluster. Those people who are grouped into the same cluster, they should have some similar property. And those people who are of 2 different group, like you can see these 2 people are belongs to 2 different group. So I can say they are having some kind of dissimilarity. So that actually signifies the process of clustering. Like when you go for character recognition, somebody is writing 7, somebody is writing 2. In that case also clustering plays a very important role. Like another technique that also very popular in under the machine learning, that is called as anomaly detection. Anomaly detection says that, like if I look into different transactions and I identify that this transaction may have some unexpected behavior, right? If you identify such type of data or such type of event or such items which is different from all other items, that is considered as an anomaly detection. So although these are coming under supervised learning, unsupervised learning, but later point of time people have come up with semi-supervised learning. In semi-supervised learning, some samples are leveled and some samples are not leveled. So when you deal such type of data, we call that as a semi-supervised learning. Similarly, there is another form of learning that is called as reinforcement learning. Reinforcement learning is nothing but if a particular system or a particular agent, we call here agent may be considered as anything, right? Which we will see in the next lecture. So agent is going to be either rewarded or agent is going to be punished. Agent will be rewarded if agent is doing good. If agent is not doing good, then agent is going to be punished. So if a agent is doing good, then I am going to reward in a particular environment, and if agent is not doing good, I am going to punish that environment. Punish that in that particular environment, so that the agent will learn from the environment and improve the solution. Like you can see here, this game also you have played in the childhood, that a person is standing here, he needs to move to this particular point to win the race. So what may be the possible ways to reach this particular place? And how many backtracking moves you are doing, how many forward movings you are doing. Based upon that, I am calculating the performance. Okay. So if you reach to this place, then I am going to reward it. If you are not going to reach within a particular duration, I am going to punish it. So this way, the reinforcement learning plays an important role. So as I mentioned, you cannot find all the things in the very first step. Okay, because machine learning has to learn from the mistakes, right? Like what may be the food of a dog that you may not find in a very first iteration, but over a particular iterations, the machine learns from the environment and find a suitable thing for a particular animal. or a particular object. So this is nothing but rewarding behavior or punishing behavior, punishing for the undesired one that we give to learn from our mistakes. Like there is a game called as AlphaGo. So AlphaGo is a computer program, right, that plays the board game Go. This board game is called as Go. So actually, or you talk about the Deep Blue. There is a IBM launched a program that is called as Deep Blue. It was played with one of the champion of chess. Like when we play computer game, one side the computer is playing, another side we are playing. So the computer is sometimes intelligent enough to defeat us also, right? Computer is so much talented that is able to defeat a particular user also. In the similar case, this AlphaGo, okay, was developed by London-based DeepMind technology, an acquired subsidiary of the Google, and it is able to identify, able to defeat the user, right? So that is that's why AlphaGo is very popular. Similarly, you can see this Deep Blue program also, when it is played with the chess champion, it is able to defeat the chess champion. No human being defeated the chess champion, right? That's why that person is champion. But it is possible for a computer program to defeat that particular game. So there are several other technologies that are also application of machine learning, like sequence predictions. When you chat with your friends, when you type some letters, then automatically some other letters are coming or words are generated. So that is an example of a sequence prediction. Similarly, sometimes we are capturing different type of photos and we play a nice music in the background, and with a set of photos and music we create a video. So that is example of a style transfer. Now what I am going to do here, I have given different techniques. Forget about whether it is a supervised or unsupervised or semi-supervised or reinforcement learning. So based upon the problem, you have to decide whether it can be solved using classification or clustering or regression or sequence prediction or style transfer. For example, I want to recommend what someone is going to download based upon the previous purchase. Like talk about any e-commerce site like Flipkart and Amazon and whatever site you like. So I want to suggest what you are going to purchase.
call messages.
I want to suggest that what you are going to purchase, right, based upon your previous purchases. So which technique you are going to apply? Can anybody tell? Like I have purchased a computer, then I have purchased a keyboard, let's say, then I have purchased a mouse. Okay, then I have purchased a mouse. Now let's say based upon this I am suggesting to purchase a headphone. Okay, now you tell which technique is used to predict this one is a headphone. 1 or 2 or 3 or 4 or 5. What is your answer? Some people says classification, some people say clustering, some people says regression. So the correct answer is what? Sequence predictions, right? Because you see, based upon the previous purchase, I am suggesting a new product. Based upon the previous items, I am suggesting. This item is suggested because you have selected a computer. You have suggested a, let's say, keyboard. This is, you have suggested a mouse, right? That's why it is suggested. That's why this is an example of a sequence prediction. Okay, now coming to the next question. If I label an email as spam or not spam, it comes under what? An email is spam or not spam? It comes under which machine learning technique? Yes, the answer is classification. Through classification, we can categorize them into spam or not spam. Okay, coming to next one, identifying the trend among a group of people. Group of people, like I mentioned that there are 200 participants are there. I want to group them into 2 different groups. First group is having, let's say, 100 people, another group is having 100. Not necessary, right? Equal number of groups, but I want to divide it into equal number of groups. So identify the trend among a group of people who have brought a new music release. is an example of the process of clustering, right? This clustering is dealing with a group of people. Now I want to caption a video like this Google Meet. It is recorded, right? And later I want to add, let's say, transcribing with it. Although Google supports nowadays with Google Meet, I want to transcribing this particular video. That means whatever I am stating, that also need to be come as a script or as a word file or a text file, so that somebody is watching this video in later point of time can also see what I am talking, right? And in the form of a text. So it is an example of which machine learning technique? Can you guess this one? Yeah, the answer is already mentioned. That is called a style transfer, because you are taking the video, you are taking the text, based upon that you are transcribing it. That is the example of a style transfer. Determining workout activity based on the phone movement, right? If I have a phone, I have to decide that whether I am working or I am not working. I am working or I am not working, because phone movement means whether phone movement is on or phone movement is off. When you keep your phone on a table, okay, or when you put your phone in some place, then it is not having any activity, right? But when you are working or you are doing some work and your phone is there in your pocket, then it is also moving, right? So when you look into workout activity, right, it is whether you are working or not working. It is an example of classification, right? Sequence prediction will come if I tell that, let's say, morning 6 to let's say evening 6 I am working or I am moving here and there, and let's say I am predicting for the next 1 hour. In that case, sequence prediction will come. So most of you answered sequence prediction, but it is not sequence prediction. It is classification. Okay, predicting the strength of a password. If I say your password, whatever you have given to a Google service, whether it is a strong password or it is a weak password, is an example of which one? Strong password, weak password. It is an example. If I say strong and weak, it is a classification, because I am leveled to strong and weak. But in general, if I say these are nothing but let's say I have taken some two-dimensional space, I am saying these are the different passwords which are very strong. So in that case, you will use regression technique to check that the next object is close to these particular other objects or not. Or if I draw a particular line, I'll check that whether it is close to that particular line or not, in order to decide whether it is a strong password or a weak password, or what is the strength of a password. If it is close to this particular line, it is a strength of the password is high. If it is very far away from the password is weak. Identifying the famous landmark in a photo. Suppose I have taken a photo in front of, let's say, Golconda Fort in Hyderabad, right? I want to identify that whether it is a Golconda Fort or not. So it is an example of a classification. Yeah, somebody said that regression, we can also view as a regression in the sense that I have kept all the famous landmarks and I draw a line. Whenever a new landmark is coming, I am checking that whether it is close to that particular line or not. In that case, you can say it is a regression. In general, it is a classification. Okay, suggesting the spelling corrections. Nowadays, we are using Grammarly or some other applications to correct the spellings. Okay, if you have made any typo, that can be identified. So there are correct words based upon that you are doing, right? So it is an example of clustering, right? Clustering helps us to correct the spelling corrections. And if you say it is a correct spelling or incorrect spelling, then classification. If it is correct or incorrect, it is classification. Clustering means if it is if you are suggesting some spelling correction. Some people can also thought of sequence predictions also. Like I typed some word, let's say let's say power. I am writing PO and it is predicting the next words are WR. PO is not a valid word, but it is suggesting some words. In that case, you can visualize it as sequence prediction. So that's why for all type of problem you need to analyze, right? Whether it is comes under one category or other category. Next is predicting the quality score for an advertisement. Okay, the different advertisements are with you, right? Based upon that, you decided that which one is having quality or not, right? And if a new advertisement is going to be given, you need to find its score. It is an example of regression, right? Regression will help you to identify, because it is going to map with already those advertisements are determined with good quality score. In that case, we call that as a with regression. Estimating the arrival time based on the time and day of traffic. Like example of Google Map. Through Google Map, I am able to identify whether I reach to my destination at what particular period of time, at particular time. It is an example of which one? Regression. Similarly, if I want to translate between two different languages, like if you know Telugu, then you can help me to convert it into, let's say, English. I am converting from Telugu to English or Telugu to Hindi or Hindi to English is an example of style transfer. Yes, all of you have answered style transfer. So like that, with respect to different applications, you can use one machine learning technique, or sometimes you can go for a set of machine learning technique to solve a particular problem. And you can see here there are several machine learning applications we have, starting from speech recognition, image recognition, traffic prediction, recommendation system, medical diagnosis, fraud detection, email spam or malware filtering. All these are some of the potential applications of the machine learning. Now, how do I start solving a problem with machine learning? That is more important, right? So obviously, first you are going to collect the data, right? Without data, you cannot do anything. So first way you can solve a machine learning problem, you have to familiarize your data. You concentrate on what are the values the data contain. Each and every feature wise, you need to identify what is the range of the data, whether any abnormality in the data, whether any outlier in the data, that you have to identify. That is nothing but familiarize with your data. Second is you have to go for the process of feature handling. So feature handling will help you to prepare the input data set, right? When you deal with a particular data set, you may identify that there are many features. Like if I go for a large data set, I may find that there are 100 features, but all features are not important. So I need to identify what are the features that are important and what are the features I can consider for developing a particular model. So according to a survey, it is mentioned that the data scientists spend 60% of their time on data preparation. That's why I told you, data pre-processing phase. Once the impure data is with you, convert it into the pure data takes 60% of the time. Rest 40% of the time you can do other work, right? So in order to go for the process of feature handling, or in order to look into different type of features, there are different type of variables are used. Some of the variable names are called as nominal variable, ordinal variable. One hot encoding is used for handling these features, or sometimes we use level or ordinal or integer encoding. I'll tell you one by one. And if you have some missing values in your data, you can apply mean method, median method, mode method, which we have studied in the statistics to solve that particular problem. For example, you may have the data which is categorical in nature. What do you mean by category? For example, if I say gender of a particular person, it may be male or female, it belongs to one or more category. Blood group of a person, it is categorical. But when you go for a nominal variable, suppose I am representing the data in the form of 1, 2, 3, 4, 5, but there is no relationship between these values, right? I am giving 1, 2, 3, 4, 5, but there is no relationship in the variable, then I can go for a nominal variable. For example, I can say Hyderabad is given as 1, Delhi is given as 2, Chennai is given as 3, let's say Mumbai is given as 4. So there is no relationship between these values 1, 2, 3, 4, just I have renamed with some particular city. But when you go for an ordinal variable, this order has some meaning. For example, I will say the best city in India is representing 1. The second best city is representing 2. Then it is considered as an ordinal variable. Another example of ordinal variable is that, suppose I will say that how satisfied are you with our meal tonight? It is very satisfied, satisfied, indifferent, dissatisfied, and very satisfied. Very dissatisfied. For example, I am giving very satisfied is, let's say, 2, satisfied is 1, indifferent is 0, dissatisfied is -1, very dissatisfied is -2. So this case, the order has a meaning. If you give a higher number, that indicates that you are fully satisfied. So that type of variable is called as ordinal variable. But sometimes what happens, many data set or data engineers, what they do, like I mentioned, I'll assign England with 1, okay, Japan with, let's say, 2, Australia with 3. So this is an inappropriate way of representing the values to a particular data. So in order to solve this problem, people use one-hot encoding. What one-hot encoding says that if the value is 0, suppose I am assigning Australia a 0, right? So you can see in this column only the third sample is having Australia, so I am getting the value 1 here, rest case it is 0. Similarly, if I assign England with 1, so first 2 samples are having England, so I am getting this value 1 here, rest value it is 0. Similarly, Japan is there in the second sample, so that value is 1. So when you represent the data in this form, we call that as a one-hot encoding of the data. But when you are given with reviews, for example, average, good, excellent, and worst, you know, excellent is having more meaning than good. Good is having good meaning than average. Average is better than the worst. So I am assigning the values based upon the different, based upon the quality or quality of the review, whether it is good review or it is excellent review, average review. So in that case, I am going to use the ordinal encoding. So unfortunately, you deal with any particular data, you will find in several issues. No data will be available in the pure form. Whenever you are collecting the data from various sources, you will find that your data has several issues. That's why you have to spend your lot of time when you go for the machine learning process to make it a pure form. So, for example, one of the popular movie you may be aware, that is called as Titanic movie, right? So there is a data set with respect to this Titanic movie, and this data set is having some of the feature like age, gender, how many siblings are there for each and every passenger, and so on, right? And based upon that, you are given with some sample, you have to predict that whether the person is survived in the Titanic incident or the person is not surviving in that incident. So when you solve this particular problem, don't directly jump into the solving this particular problem, because you need to understand the data very carefully. So real life data sets are almost always have machine values. For example, for some particular passengers, age is not recorded. Okay, for some passenger, maybe their gender is not recorded. So you need to resolve this data before applying any kind of machine learning model into this dynamic data set. Okay, so sometimes the data may be corrected, sometimes the data may get some outlier. You need to remove this one before applying any particular model. And sometimes, in order to go for make the data consistent, we use some statistical approaches. Like we can apply mean. You know, mean is nothing but the average. You take all the values, average the values, and put in those locations where you have missing values. Okay, for example, here you can see I have taken a data and I found that average age in this Titanic data set is 29. So I put, let's say, this particular location, the data is missing. So I am putting the average of that particular data, that is 29.699118. Right? What is the demerits? The main demerit in the mean is that we are taking an average, right? Although it is a good measure, but this measure is heavily dependent and extremely sensitive for the outlier present in the data set. What do you mean by outlier? For example, one person has by mistakenly entered the age is 165. So it is going to influence your mean whenever you are calculating the mean of the a set of people. So that is the major drawbacks you are going to find. As an alternative, you can go for median, right? So median is also a statistical measure. Rather than finding the mean, you have to sort the data into one particular order and find the mid value. But again, this method has some drawbacks, like it does not factor the correlations between various features, and sometimes it results poor results also. As an alternate measure, you can go for the mode imputation technique also. Mode is nothing but how frequent a particular item is repeated in a particular data set. For example, maximum time, let's say age 20 is repeated. So I consider that 20 as the value for the missing values, right? That way also I can do, but again, it is not also best method. So in a particular data set, you can try various type of imputation technique like mean, median, and mode, and find that which particular technique is correctly predicting your classes. This way, we can solve the missing values in the data set. So in this first lecture, what we have discussed about what is machine learning, what is the main motivation. We compare the machine learning system with the rule-based system. We have seen the end-to-end process of implementing the machine learning algorithms. We have seen the relationship between AI, ML, and deep learning. We have seen different type of machine learning techniques like classification, clustering, regression, sequence prediction, and style transfer. And I also told you different type of machine learning techniques like supervised learning, unsupervised learning, reinforcement learning, and semi-supervised learning. Okay, thank you everyone. So this is the end of the first talk. If you have any question, you can ask. Yeah, any participant having any question, you can write in the chat box or you can unmute and ask. Okay, so if you don't have any question, then we'll take a break of 10 minutes and we'll start the next session.
Yes, sir.
Okay?
Yes.
We start by 8:40. Yeah, thank you everyone.
Dear participant, please don't go anywhere. Again, the session will resume from 8:40.
So good evening, everyone. Am I audible?
Yes, sir.
Okay.
Yes, sir.
Okay, madam.
Yes, sir.
Okay, thank you. So let us start the second session. So the title of this session is that we'll see the traditional AI to the latest innovation of AI, that is agentic AI. And also I found one question in the chat box. The question which I am going to address in this session, which is inclined with this topic, that is how agentic AI will change the machine learning and deep learning applications. That we'll discuss in this session, because this topic is giving you the highlight from the traditional artificial intelligence to the latest development in the field of AI, which is agentic AI. So these are the topics that we'll discuss. I'll start with a small roadmap starting from 1950, from the birth of artificial intelligence, to 2025 and 25 ahead, like 2030, where you can find the agentic AI. Then, in order to understand the concept of agentic AI, you need to understand what is an agent. In fact, in traditional AI, we have agent, we have environment, we have different problem formulations. First, we'll discuss about these traditional part of artificial intelligence. Then I'll introduce what is agentic AI. I'll show you two examples through which you can understand agentic AI in a better way. The first example is related to personal travel assistant. Like a person wants to go somewhere during holidays, and how agentic AI help us to book the tickets, plan this particular travel. The second example is that in a company, a manager wants to conduct a meeting with several co-workers. And in order to schedule this particular meeting, the manager wants a common slot among all these team workers. And these team workers are present in different domains. Domains means I want to say they may be having different expertise, they may have different time zones, they have different experience. So how agentic AI will help us to make this a smart meeting scheduler. Then once you understand these examples, I will formally tell you what is how agentic AI actually works, what are the step-by-step process. And you know that generative AI is also one of the latest technology. So you may be greedy to know how generative AI is different from agentic AI. What is the difference between these two technology? And also I'll tell you about some of the applications, use cases. I'll show you a agentic AI system and how agentic AI can be integrated into the scheduling problem. Various kind of scheduling problem, like meeting, smart meeting scheduling is also one type of scheduling problem which can be solved using agentic AI. So let us start with the roadmap. So all of you may ever that in 1957 there is a conference in that John Hall, the father of artificial intelligence, okay, has introduced this keyword called as AI. His name is called as John McAfee. He is considered as the father of artificial intelligence because in that conference he introduced the term artificial intelligence. So if you go for the development after the birth of artificial intelligence during 1956 to 1970, you can find more or less AI is considered as a rule-based system. And I told you clearly that what is a rule-based system. Rule-based systems, are nothing but if-then clause. If a condition is satisfied, then what is the corresponding action you are going to apply? Okay. For example, if like mentioned that if object height is greater than 10 centimeter, then the object is considered as X. If object color is equal to blue, then it is considered as Y, and so on. So in 1956, after innovations, whatever the applications came, mostly in the form of expert system. Like in the healthcare domain, there is a system called as MySyn. MySyn is considered as one of the earliest export system, which simplify the questionnaires asked by different healthcare professions. Like you go to hospital, doctor asks us several questions. So MySyn is a system which has the similar type of questions. Like during COVID-19, also government released one particular application in which there are 24 questionnaires. If you answer some of these questionnaires, and if you found that into 12 or more questionnaires your answer is yes, then you may be a moderate to severe patient in line with the COVID-19 guidelines. But if it is below 12, so you need not worry, right? Similar type of things was done in MySyn. So you have to interact with the system. The system will predict you some medicines, and this system is this system is developed by taking the opinion of different healthcare professions. So whatever may be the development, as I mentioned, it is a if-then rule. So the problem is that if you go for any real life situation, everything cannot be encoded as a if-then rule. I cannot encode all type of problem into if-then rule, right? So machine learning systems are not developed during that particular time, because 1970 there is no machine learning, right? So all the systems which is developed in AI, whether you talk about natural language processing or you talk about speech recognition, image recognition, all these things are done based upon the if-then rule. So there are several drawbacks because you need to put some kind of explicit programming. There is no learning concept, no adaptability concept during those days. Now, when 1980 to 1990 era came, people have come up with the knowledge-based system. So knowledge-based system is having a knowledge base. It is having a truth maintenance system. The responsibility of truth maintenance system to ensure that whatever knowledge available in the knowledge base, they should be in pure form. Like if I say P is true, and later point of time if I say P is false, so it is the responsibility of truth maintenance system is to update the knowledge as P is false. Apart from that, there is a classical planning system. Like you are given with a source space. In that source space, you want to find a particular object. Like in your institute campus, you want to find a particular student. So you need your source space is nothing but your institute boundary, and the person to whom you are going to find, the person is your object, or the person is your goal, right? If you identify, then the goal is satisfied, otherwise the goal is not satisfied. So when you look into this space source problem, there are two types of space source problem. One is called a state space source problem, another is called as plan space source problem. These are coming under the classical planning method. A problem can be solved by dividing it into the sub problems, or by combining different sub problems, I can formulate a problem. And on those days, we use different kind of symbols. Like if you know about propositional logic or predicate logic, these logics are developed during those days, where the knowledge is kept into the knowledge base by representing it in the form of some kind of symbols. That's why we can call that the symbolic based artificial intelligence also sometimes we say. But in this case also, the AI has no autonomy, right? There is no perception in the system, there is no feedback, nothing. So such systems are developed and used by various applications, but that is not having that much power to learn or find different kind of pattern or find different kind of autonomy. That's why in 1990 to 2000, people have come up with statistical artificial intelligence and machine learning. And you know, like I mentioned that IBM Deep Blue program, which was played, this is a computer program played against the chess champion, Garry Kasparov, and the program is able to defeat the chess champion. Right? So program is not explicitly programmed. I cannot go for all possible number of cases. Practically going for all possible number of cases is not a wise solution, right? Because there are many problems are there in our domain. You will find that years to solve if you go for all possible way of solving that particular problem. So no doubt you have now data, and machine is able to learn from the data, but model can be learned from that particular data, but still it lacks from goal setting as well as self-directed behavior. Agent cannot work. Agent cannot have an autonomy to apply its self-directed behavior. That type of things are not there in a machine learning based system. So in 2010, in 2015, during that, people have come up with another techniques, which is a subset of machine learning that is called as deep learning. And you may be aware of different machine learning model like convolutional neural network or AlexNet and ImageNet. So when AlexNet with ImageNet, they found that AlexNet wins against the ImageNet. And deep neural network outperform the classical machine learning approach. That's why in today's era also neural network plays a very important role. And if you go for deep learning, we use different type of neural networks, right? So AI has improved in this era of deep learning, but again, it is applicable for a simple task. But when you give a complex task, it is not able to recognize it. Now, after 2015, during 2016 to 2020, people have come up with another type of learning called as reinforcement learning. Just before this talk also I mentioned about reinforcement learning, which reward the particular agent if agent is doing satisfactory job. If agent is not performing well, agent is going to be punished. So agent start working in a particular environment. Agent has some perception. Agent perceive a particular environment, knows about the environment, and applying certain action into that particular environment. But the major limitation is that agent need to be trained with a very large amount of data, and it is not adaptable. If you design a particular agent for a application, and if I go for other applications, it is not applicable. Now, during the era of 2021 to 2023, you know, GPT plays a very important role. That is called a generative pre-trained transformer model. GPT-1, GPT-2, GPT-3, nowadays we talk about GPT-4 came into the picture. So these models primarily focus on how to generate different kind of content. You ask any questions, it can be generate different type of content. Like if you remember, there is a test called as Alan Turing test. And you know, in computer science, the highest honored award is ACM Turing Award. It is given with the name of Alan Turing. So Alan Turing visualized what we are using nowadays as ChatGPT. Alan Turing mentioned that in 1950, around 1950, he mentioned that there is a test called as Alan Turing test, which says that in two consecutive rooms, let's say one room you are considered as a evaluator or an interrogator, you have to ask some questions to the person who is there in the other room. But whether there is a person available in other room or a computer is available in other room, that you do not know. Right? Assume that two consecutive rooms, you are sitting in another one room with a computer, you are asking some questions which is replied by a person or a computer who is present in other room. After let's say a 30 minutes of conversations, if I ask, after 30 minutes of conversation, if I ask that whether there is a human being in other room or there is a computer. Suppose you mentioned that there is a human being, but actually there is a computer. Then we can say your Turing test is satisfied. So based upon that, there is a competition in United States of America called as Loebner Prize. It is a $1 million competition. Every year this competition is conducted, and around the globe people are participating to show the model accuracy. The way that what we are saying nowadays about ChatGPT. The same thing I am talking here is a Turing test, but Turing test was proposed long back, but till now we are looking for the solutions with respect to Turing test, and ChatGPT is also a solution. But the problem with generative AI or this ChatGPT is that it is generating the content. It is generating the content, but it is not fulfilling your goal. Suppose my goal is to book a ticket. If I ask the ChatGPT how to book a ticket, it is going to give me a set of steps, or by following that particular steps, I can book a ticket. But it is not going to book my ticket. That's why the agentic AI come into the picture. So agentic AI primarily focus on not the goal, it is also focuses on the sub goal. It is not only generating the content by using the generative AI, but also efficiently plan your travel. Efficiently plan your travel. Everything is self-directed. Everything is considered in a planned manner. everything is considered as a self-directed behavior. That's why agentic AI is going to be the future of artificial intelligence. So in the era of 2025 to 2030, we expect that not only agentic AI is going to grow, because you can book your ticket using agentic AI, you can plan your let's say vacation using agentic AI, you can plan a meeting using agentic AI, but also this agentic AI is going to integrate with various physical environment. Like you can say various cyber physical systems are there, like IoT is there, robotics are there. All these will be interacted with the agentic AI platform. Okay, through which we are going to deploy. Okay, we are going to deploy a model through agentic AI to solve the different type of applications or domains, or the problems of different domains like education, healthcare, and manufacturing. So what is the main vision of this agentic AI? AI that has not only act but also regions, adapts, collaborate across various domains. You might develop a model which is more suitable for, let's say, healthcare domain. But when I apply the similar type of model in other domain, it is not working. So AI is expected to do all these things with the self-directed behavior, with goal setting, with designing different kind of goals and different type of problems. But in order to understand the concept of agentic AI, as the word is agent, so you need to understand that in traditional AI, what is an agent and what is an environment. You can see this example, like I consider an agent is anything that can be viewed as perceiving its environment. Like as a human being, I can consider myself as an agent. I am perceiving the environment. Like you can see, this is an agent. I am perceiving this particular environment. How you are going to perceive an environment as a human being? You can perceive the environment because you have eye. You perceive the environment because you have ear. You have perceived environment because you have a mouth, you have a tongue, right? All these will help you to perceive the environment. You can taste, you can smell. All these things are nothing but we carry out with different organs. That's why we can perceive the environment. If I perceive the environment, then what I am going to do? Once I perceive the environment, I am going to apply different kind of actions into the environment. What do you mean by different kind of actions? For example, I am walking in a particular street and I found a snake. I found a snake. Then through my eye, I am able to identify that there is a snake in my environment. What I'll do? I'll run away from that particular place, or I'll change my directions. So that can be done through my leg, or some cases I can use hand, some case I can use mouth, I can shout, so that I can move from one place to other place, or that place to other place. So we can apply certain actions into the environment through actuators or the effectors. Actuators or effectors are used to apply certain things into the environment. Right? Now, there are different type of agents. If you go for a rational agent says that it does the right thing. Rational agent does the right thing. Now, question arises that what is right thing? Like I am driving a particular taxi, I have to reach to my destination. I have to reach my destination with a certain time. Let's say I violated traffic law and I reach to my destination. My goal is satisfied. My goal is to reach the destination with certain time. Very satisfied. That is right thing for that particular agent, the taxi agent. But another taxi agent says that I will reach to the destination. It might take lot of time, but I will not violate the traffic law. That is the right thing for other agent. So every agent has certain goal. Based upon this goal, I can decide that which one is right, which one is not right. So we'll say that right action is one that will cause the agent to be more successful. If the agent feels that violating the traffic law is more successful, then that will be considered as right thing. If the agent feels that no, I will not violate the traffic law, then that is considered as more successful. So whatever work you can carry out, that based upon that we can decide which one is successful, which one is not successful. Now, whether an agent is successful or not, you are given with the agent, but whether the agent is successful or not, how you are going to determine? In order to determine, you need to identify how to evaluate the agent success and when to evaluate agent success. So there are two clauses you can see here. One is how, another is when. For example, if I take an example of a vacuum cleaner, all of you know vacuum cleaners are used to clean the surface. So I am putting a performance measure by stating that how much garbage or dirt cleaned up in single 8-hour shift. In a 8-hour shift, how much dirt is collected? That is my that is going to determine whether my agent is successful or not. That may be one of the parameters. Somebody will say that I am going to evaluate the vacuum cleaner based upon the electricity consumed by that vacuum cleaner. That is another way of defining. Another way I can say the amount of noise generated by that particular vacuum cleaner. That is also another way. So there may be different kinds of the performance measure you need to consider to calculate the agent's success. Now, when to evaluate the agent success? So I will tell I am not going to wait for 8 hours. For every hour, I will see how much dirt is collected by that particular vacuum cleaner. So at what point of time you are going to evaluate? That you need to determine, right? So based upon that, you are going to reward a particular agent who is working first and punish the agent who is not performing well, or punish the agent who is performing consistently. So this way we can decide that how and when I am going to evaluate a particular agent, whether the agent is successful or the agent is not successful using different performance measure. There is another type of agent which we call as omniscient agent. What do you mean by omniscient? Omniscient means if you know the actual outcome of its action. Okay, based upon that I am going to act accordingly. For example, suppose I am crossing a particular road. So in my lifetime, many times I am crossing the road. So crossing the road is always successful. So today also I crossed the road. That's why I feel that that is successful. My crossing the road is very successful. But let's say an agent has an accident while crossing the road. But the agent has crossed the road many times. The agent has seen that there is no traffic, trying to cross the particular road, but has an accident. So, can we say that that agent is irrational to cross the street? The answer is no. We cannot say. Right? So, omniscient agent says that if you cross the road today and if you predict that I may face with an accident, then that is called as omniscient agent. That means it is impossible in reality. What is the actual outcome that we cannot know, right? It's very difficult to know, right? What will happen then that in future that we do not know. So crossing the street was rational because most of the time it was successful. But if I predict that crossing the road is unsuccessful, then that particular agent will be considered as an omniscient agent. So you may ask if omniscient agent is not practically possible, then why you are calling that as omniscient agent, or why we are thinking of omniscient agent? The reason is that we want to reach to a agent. Okay, we want to make our agent closely to the performance of an omniscient agent. We cannot make an omniscient agent, but we can reach to if appropriate close to that particular agent decision. Then we will say that yes, it is taking a good decision compared to other agent. So what is rational at any given time is depends upon the four things. First one, if you take a performance measure is actually defining what is the degree of success. Like electricity consumption, noise creation, all these are considered as some of the performance measure. Second one is saying everything the agent has perceived so far. The agent further decision is depend upon what is the decision taken in the past. So for this, we are maintaining the perceptual history of the agent. How to maintain the perceptual history of an agent? we can maintain the perceptual history based upon the percept sequence. Like if you take a robotic application, if I instruct the robot move left, then move right, go straight, then back. So if the robot is now doing a left operation, then right operation, these are nothing but my perceptual history. Now the robot is taking forward direction. So that is my percept sequence. Third part, he says that when an agent is working in a particular environment, what the agent knows about the environment. Sometimes, like when you play a particular game, the game is so complex, you may not visualize all the possible moves, right? So in that case, the environment that you are working is considered as a partially observable environment. But sometimes we play a tic-tac-toe type of game. It is a very simple game, right? Where agent has fully explored the environment. So that is also one of the parameters. Fourth one, the action that the agent can perform. What action the agent can perform at a particular state. Agent cannot apply all the action in all the states. That is not practically possible. So what action the agent can perform, that is considered as what are the applicable actions in each and every state. That also makes whether an agent is rational or irrational. So there is another agent which is called as ideal rational agent. Okay, it is called as an ideal rational agent. What ideal rational agent will do? It will apply the actions which leads to maximize the performance measure. Okay, maximize means optimize the performance measure, right? If it is a maximize parameter, we will maximize. If it is a minimize parameter, we will minimize, right? So if you take a performance measure and if you tell an ideal rational agent, I want to maximize this performance measure, so it will tell you what kind of actions you are going to apply so as to maximize your measure. Okay, how to achieve the maximum value, right? So sometimes this agent is also having some type of knowledge that is called as built-in knowledge. Normally, whenever the agent work in a particular environment, so some built-in knowledge is given to that particular agent. So the mapping is required between the percept sequence and action. For what percept sequence I am going to apply what kind of action that need to be mapped. I'll show you with an example to understand. Like here you can see, this shows how to calculate square root of a particular number. I have taken a function. You have to calculate a square root of a particular number, let's say x. If x value is given to the square root function, it is going to initialize z is equal to 1. Then it is going to calculate z square minus x modulus is less than 10 to the power minus 15. If this condition is satisfied, then it is going to calculate z is equal to z minus z square minus x by 2z. And this process is going to be repeated unless this condition is not satisfied. And finally, I am going to return the value of z. Now, I am giving this x value as 1, which I call as percept. In my percept sequence, I have given the value as 1. So whenever you give the value as 1, this function is returning the action as 1. Whenever you are giving x value is equal to 1, the corresponding action it is returning is z is equal to 1. But if I give x value as 1.1, then it is returning the z value as 1.04 and something. Similarly, if the x value is 1.2, then it will be generating 1.09 and so on. So the question arises here, what do you mean by built-in knowledge? Like, I have explored all the values after decimal place if I take one digit between 1 and 2, excluding 2. So I have explored all the things. If I ensure that x value lies in between 1.0 and 1.9, or let's say 2.0, then I have explored all the percepts. You will not find another value of x except this particular range. You will not find a value in this particular range which is not covered here. Assume that you are taking only one decimal place. So if the agent action are based on only the built-in knowledge, now when I take all these one, then there is no need of this particular procedure. So my agent action is based upon this built-in knowledge. So in that case, what is going to happen? It autonomy needs no attention. Its autonomy comes here. But I am not paying any attention. So we say that agent lacks the autonomy. Okay, in this case, agent lacks the autonomy because if anything goes beyond this one, the corresponding percept you will not find. If you don't find the corresponding percept, then you will not apply the corresponding action. One of the simple example also I have mentioned here. For example, a person is moving from, let's say, India to Australia. Okay, India to Australia. Now, the time difference between India to Australia is 6 hours. And the person who is traveling from India to Australia wear a watch. When the person is in India, the watch shows Indian Standard Time. When the person reaches to Australia, the clock is also showing Indian Standard Time. So what you can say? Agent lacks autonomy, right? Why the clock is showing Indian Standard Time? Because the clock is not having intelligence to change the time. It is not able to retrieve the local location. Based upon the local location, it can change the time, right? So here you can say clock is not intelligent, or the clock designer has not put this intelligence. So we can say intelligence seems to belongs to the clock designer rather than the clock itself. Clock designer has to make the clock intelligent enough so that whenever it reaches to a different country, it has to set based upon the local time. So in this context, when you see the structure of an intelligent agent, it is nothing but sum of two things. One is architecture, another is the program. So agent is considered a sum of architecture plus program. Which architecture it is going to work? What program enable it to apply some kind of action, or what program help you to perceive a particular environment, that you have to determine. Now here you can see I am giving you different agent types and their percept, action, goal and environment. Let us discuss one. Like if I go for a medical diagnosis system, who may be the percept? Why a patient is going to medical diagnosis system? Because the person is having symptoms. The doctor will ask some kind of questions. There are some findings. What kind of actions we can apply in this particular agent? Doctor will post different kind of questions. Doctor will recommend test. Doctor will recommend some kind of treatments. What is our goal? The goal is to make the patient healthy. The goal is to clean the environment, clean the medical diagnosis system. The goal is to minimize the cost of a patient. And in environment, doctor is a agent, patient is a agent, hospital system is also considered as hospital is considered as an environment. Rest are considered as an agent. Like that, for every type of agent type, what you have to do, you have to determine what is the percept, what is the action, what is the environment. Now one question arises here, why not we look into the answers? What is the meaning of answers? Like if you go for a chess game, it is considered that the number of moves, we are moving these elements, right? If it is a two-player game, like one player is playing against another player, a chess game, right? So average number of entries they are making is 50 entries. Average number of entries both players make is 50. So it is 50 plus 50 is 100. Number of entries for two-player game is in average it is 100. So if I create a built-in table just like previous one showing percept X and action Z. Okay. So this 50 different entries of individual player and 100 entries as a whole has how many entries in this particular table? It will be 35 to the power 100 entries. 35 to the power 100 entries. And if let's say, whenever I am selecting a particular X to find its corresponding X on Z, like in the previous case, if the X value is 1, I am saying the Z value is also 1. So when I go for 35 to the 100 entries, I will check with these entries. If I found a particular entry, corresponding action is going to be executed. So if each entry takes 1 second of time, you will not get a solution in your lifetime. That's why it says that it takes a lot of time for a designer to build this table. Even if you build this particular table, okay, and you are going for matching each and every value of X, it takes a lot of time. Right or not? So, and in this case, if you go for a built-in knowledge by creating this particular table, then agent lost the autonomy. If something happened beyond this 35 to 100 entries, then agent do not know what is going to be done in that particular case. So in fact, there is no learning mechanism if you go for exploring all possible number of states. That is the reason why we are not looked into the answers. Now take an example of a taxi driver. Taxi driver is an example. What may be the percept? The driver is having look into camera. Taxi is having a speedometer, GPS, sonar, microphone. These are nothing but percepts. What kind of action the agent can apply? The agent can apply steering, accelerate, brake, talk to passenger, and the goal is to make the trip comfortable, safely reach to your destination, following all the legal procedures without violating any traffic law and everything. Now, as I mentioned earlier also, when I talk about multiple taxi drivers, they have their desirable qualities to reach to the correct destination. Like one may say that I can reach to the destination with minimum fuel, and there is minimum wear and tear of the vehicle. Somebody can say that I can minimize the trip time. Somebody can say that I will minimize the violation of traffic laws. Somebody will say that I have both things, safety and passenger comfort. Somebody will say that profit is another criteria. So sometimes what happens, we are not only relying on one particular objective, but we are relying on more than one objective. I want to minimize the violation, as let's say minimize the fuel consumption. Right? So when there is a conflicting objective, we use some kind of utility functions to resolve this particular type of problem. And sometimes we have to ensure that if a model is applicable for a particular environment, and if the environment is changed, then whether the same agent will work in that particular environment or not. For example, in some countries, the driver is sitting in the right side. In some countries, like if you go for Britain and Japan, driver is sitting in the left side. So if you develop a model for a driving system where the driver is sitting in the right side, whether the same model will work in the countries where the driver is sitting in the left side, that is quite challenging. So based upon that, you can see the agent program is divided into 4 types. The 4 types are nothing but simple reflex agent, model based reflex agent, goal based agent, utility based agent. These are the 4 different types of agent. Apart from that, we have another agent, because these agents do not have any learning behavior. So we have learning agent. So quickly I'll tell you one agent, one by one agent. What is simple reflex agent? Simple reflex agent is nothing but our if then rule. For example, you can see there is an agent here. Agent is perceiving this environment through sensor, and agent is applying some actions into the environment through actuator or effector. So when the agent perceives this particular environment, then the agent is asking a question, because sensor is collecting the data. Sensor is nothing but our eye is also considered as a sensor. The question asking here, what the world is like now. And once you answer this one, you can apply some action into the environment. What action you are going to apply? That is based upon the condition action rule. Condition action rule is nothing but percept is X, action is Z. For example, if the car in front of me is braking, I am driving a car, the car which is in front of me is initiating braking process, then I will also initiate braking. If car in front of me is not braking, then I will not also initiate braking. So in this case, what is the main drawbacks? Everything cannot be modeled in the form of condition action rule. Everything you cannot model in the form of condition action rule. If you can model it, which is suitable for rule-based system, then simplest reflex agent the best option. Okay, otherwise, simple reflex agent is not directly applicable. Right? Now, what is the solution? The solution is that, okay, if you go for the solution is that I cannot capture in the condition action rule. So what I'll do? I'll go for another type of agent which can keep the states. Like here you can see it is an extension of the previous agent which is called as reflex agent with state. Means what the world is like now is defined in terms of several states. So the only difference between the previous agent program and this agent program is that previous one, the current situation is based upon the percept only. But this one, it is based upon the percept as well as some internal states. Based upon that, I am going to apply the action. But still, you are relying on the condition action rule. Everything cannot be modeled in the form of condition action rule. That's why we have come up with another agent that is called as a goal-based agent. What goal-based agent is going to do? For example, if you are present in a 4 square, let's say a vehicle is coming this way. So either the vehicle can move left, or the vehicle can move right, or the vehicle can go straight. So previous agent program, you have seen that what the world is like now. It is defined in terms of various states. But here we added another one stating that what it will be if I do action A. Let's say this is my action A, this is my action B, and this is my action C. What it will be if I do action A, and how happy I will be in such state is nothing but the another agent program. So if I take action A, whether I will be able to reach to my destination. If I apply B, whether I can reach to my goal. If I apply C, whether I can comfortably reach to the C with my goal. It may happen that there is a path where the road condition is not good, but you do not have any toll tax. It may happen that there is another route where toll tax is there and road condition is good. Another case, there is a long path, okay, without any, let's say, toll gate, but road condition is good. So at a road junction, the taxi can take a decision that which action it is going to do. And what action the agent is going to do, it is depend upon the goal. Suppose the agent taking A, it is going to a safer site. B, it is a costlier site. C, it is minimizing the traffic loss. These are different goals. So agent need to decide what action I am going to apply. The fourth type of agent is called as utility-based agent. What utility-based agent says that it is taking as an utility. What is utility? As I am applying, let's say, action A, I am raising a question here that how happy I will be in such state. If I am applying action A, wherever the state I will reach, how happy I will be in such state. So it is based upon some utility factor. Like somebody will say that I need safer way of reaching my destination and I want to reach my destination in a very high speed. So then speed and safety is considered as a conflicting goal. So when you have two objectives and you have a conflicting goal, there you can apply a utility function. The utility function is going to make a trade-off between speed and safety. So although all these type of agents are there are 4 type of agent programs are there, but none of the agent program we have a learning agent. So in order to go for this learning agent, there is a different agent than these 4 type of agent. You can see there is a learning component here. What this learning component is responsible? It is responsible to improve the performance of learning in a particular environment. And it is supported by other component like critic. Critic is providing the feedback to this learning element. We have performance element. It is responsible for applying different kind of actions. especially the external actions. Like that's why you are changing the different type of actions, or you are updating different kind of knowledge. And problem generator is responsible for suggesting different kind of actions. So it makes that learning the environment is much better way compared to all other type of agent. So these are nothing but some traditional agents. Now we are looking for what is an environment and what are the different type of properties. Because agent may not look into all the parts of the environment. Like as a human being, our eye can see, let's say, up to 200 meters. So what is going to happen after 200 meters in a road, I do not know. That's why we should know what is the properties of the environment. So properties of environment is divided into 5 parts. Either it is accessible or inaccessible. If all states are accessible, just like a TikTok toy game or a puzzle game, or you take a chess game, all states are accessible. Agent sensor is able to recognize all the states, then it is called as accessible. If not, we call that as inaccessible. Similarly, we have a deterministic agent or non-deterministic agent. Deterministic agent means when your next state of the environment is depend fully on the current state. Next state is depend upon your current state, then it is deterministic. But when it is not determined, then that is called as non-deterministic. When you can apply a action and you can reach to multiple states, that is called as non-deterministic. Similarly, we have episodic and non-episodic. If you are given a particular problem or a experience you have with respect to solving a problem, which you can divide into number of episodes. Like chess, I am moving a particular element. I can consider each and every move as an episode. Then I can say it is episodic. When I cannot do that one, I cannot represent it in the form of different episode, I call that as a non-episodic. So you need to decide which one is episodic, which one is non-episodic. Similarly, when you are working in a particular environment, when you are working in a particular environment, if whatever elements are available in that particular environment is not moving, then we call that as a static agent. But when you are working in a particular environment where other people are also moving, your opponent is also moving, or environment is also moving or expanding, that is called as a dynamic environment. Similarly, we may have a discrete environment or a continuous environment. For example, I am playing a chess, is considered as a discrete. But when I am looking into the taxi driving, it is considered as a continuous environment. So I can say here that a problem is said to be a hard problem if it is inaccessible, non-deterministic, non-episodic, dynamic, and continuous. And one of such problem is called as taxi driving. Taxi driving is considered as inaccessible, non-deterministic, non-episodic, static, and discrete environment. So solving this problem is quite challenging. Now, we know about agent, we know about environment. What is a problem? A problem can be defined as if you have a goal and set of means for achieving that particular goal is called as a problem. A problem is nothing but I have a goal and I have different ways to achieve that particular goal. Okay, for that you need to formulate the goal. You need to take an agent who can solve this particular problem, which is called as problem solving agent. So after formulating the goal and the problem to solve, the agent called for a source procedure to solve it. Because the agent has to find that particular goal. For that, the source procedures are required. So now, in order to formulate a particular problem, there are 4 types of problem you can see here. One is called a single state problem, multi-state problem, contingency problem, exploration problem. Single state problems are deterministic and fully observable. Multiple state are non-observable. Contingency problem are non-deterministic and partially observable. Exploration problems are having unknown state space. Now, one by one, I'll tell you with an example. Let us consider that a world consists of two different locations. This is location 1. This can be considered location 2. So each location may have some garbage. Like this is some garbage. This location is also having some garbage. Right? And agent, let's say this is an agent. Agent I am considering is, let's say, a vacuum cleaner agent. So vacuum cleaner, which I represent here B, it can be present in the left side or right side. So if I consider this particular problem, there are 8 possible states. 8 possible states, because you can apply 3 different possible actions in these 2 states. 2 divided 3 is 8. So what actions you can apply? The agent can move from left to right. Agent can move from right to left. Okay. Or agent can collect this particular garbage or dirt. This is the thing the agent can apply. Now, these are the possible states. Which one is your goal state? If there is no garbage in left side or right side, it doesn't matter whether the vacuum cleaner is present in the left or right. Then the problem is solved. Now, with respect to this problem, let us understand what is a single state problem. So what is a single state problem? Single state problem says that, okay, for example, if you are present in state number 5, left side there is no garbage, but right side there is a garbage. Left side no garbage, right side there is a garbage. So what action you will apply from state 5 to reach to one of the state, let's say state number 7 or state number 8. So obviously you will say that I will apply right. If you make right, then it is same as 6. And if you apply sock, then you will reach to 8. So this problem is called as a single state problem. But irrespective of the state you are present, if you apply right sock, left sock, you will be reached to state number 7 or state number 8. This is called as a multi-state problem, or it is called as a conformant problem. Third type of problem is called as a contingency problem. Contingency problem says that if you are present in a state, okay, in which there is no garbage, but when you apply the sock, it is going to dirty a clean carpet. So you have to sense. In sense, if you found that there is some dirt present in your location, then only you are going to apply sock. That's why it says that right, if that, then only you apply the sock. So that type of problem is called as contingency problem. And the problem in which you search for the solutions is called as your exploration problem. So this is a state space graph where that is representing all 8 states, where you can apply left, right and sock operation. Okay, like in this state, if I apply left, so vacuum cleaner cannot move left, so I am putting a self loop. But when I am applying right, it will be look like this particular state. So I have designed a state space by taking all possible actions in each and every state. Now, in order to define a problem, okay, you need to define what is my initial state, what is the successor function that you are going to apply to reach to the next state, what about your state space, what is the path from your initial state to the final state, what may be the path cost, okay, and once you calculate the path cost and you calculate the search cost, how much cost you are incurring for searching a particular goal, if you sum it, then it will be calculated as a total cost. So if somebody is providing a solution with less total cost, then it is obviously a better solution. Like here you can see my goal. Suppose I am present in a city called as Arar, and I want to reach to a city called as Bucharest. I am finding all possible paths to reach to the Bucharest by applying the different successor function. So I can say once I reach to the Bucharest, I will calculate how much cost I have incurred for search, how much cost I incurred per path. If I sum it, I will calculate the total cost. So this kind of problem is considered as an exploration problem. So with this background, I will tell you about, okay, with this idea, what I am going to apply, I am telling you about how agentic AI is related to here. So in the past lecture, I have told you about large language model. I told you about machine learning. And many companies, they need enterprise automation. Okay, we tried automation from long years, right? But it is not fully automated, right? Still human beings are associated with all the operations. So when I am integrating large language model, machine learning, enterprise automation with agentic AI to create a autonomous AI agent. What do you mean by autonomous? Like, you know, we call autonomous university, autonomous institute, autonomous college. Autonomous means you have the capability of taking some kind of decision. You can set your goal. Okay. So when you have such capability, that is called as autonomous AI agent. And that autonomous AI agent is not only successful in the structured environment, but also it is you can say it is applicable for unstructured environment. What is the unstructured environment? Our rule-based system is considered as an unstructured environment. Sorry, it is taking its own decision. Yes, somebody has written its own decision. Structured environment is a rule-based system. But if the agent is working in an unstructured environment, taking some kind of decisions, then we call that as an autonomous AI agent. And such type of agent do not need any supervision. Even if there is supervision is required, that is called as limited supervision. So LEAI systems are rule-based system. Machine learning adapted because of the patterns, right? And LLM came with generating different kind of content. But nowadays we want to combine all these things, all these features of large language model, machine learning, and want to give the solution in the real-time process, real-time basis through an end-to-end process with limited supervision. That is the evolution of agentic AI. Now let us take a simple example that will help you to understand what is agentic AI. Imagine somebody wants to go for a vacation and the person has typed this thing in ChatGPT. Okay, the person opened the ChatGPT and typed, I want to go on a relaxing beach holiday next month. Okay, he has not mentioned the date, any date is fine, but the budget is limited to $2,000. Budget is limited to $2,000. What ChatGPT is going to tell you? ChatGPT is going to find the locations that are close to a beach and giving you a list of beach destinations, right? It can also tell you if somebody has given some travel deal that is available in the public domain. It will say that Make My Trip is giving you a deal that you can go to this place with 1800 USD, $1,800, which fits your budget. But the major drawbacks of the regular AI system, including generative AI, is that it leaves you to book everything manually. But what do we want? We want that everything need to be booked by the agentic AI platform. Agentic AI should work like a human travel agent. Like you go to a travel agent, you give your specification, like I want to go to a beach and my travel is in the next month and I can spend maximum of 200 USD. So the travel agent do everything for you, right? It is searching for destination. It is showing you different destination. It is booking for you flight ticket. It is finding the good accommodation. It is creating your itinerary, food, everything is done from the starting to ending. And if anything goes wrong, if a flight is delayed, if something is cancelled, the agent will take care of that. That's what actually human travel agent is doing. The same thing we want to achieve in agentic AI. So agentic AI is going to do with limited supervision. If it is going with full supervision, then supervised learning techniques are there, right? It is going to give you the confirmation, reminders, everything it will do based upon your choice. That we are imagining through agentic AI platform. Why it is called agentic? The reason is that it understands your goal just like an agent. That's why I told you how an agent is working in the environment. Right? It takes initiatives on behalf of you. It is taking decisions because of you. It is adapting, changing any changes happen in the environment. If any uncertainty is there, if any fuzziness is there, that is also it is controlling. That is the reason it is considered as an autonomous agent. Now, coming to the second one. If I go for a smart meeting scheduler, here agentic AI is in action. Like I have, let's say, 10 team members, or assume that in your department you have 10 faculties, but these faculties are now present in 3 time zones. One may be at India, another may be at US, another may be at UK. So you have to schedule a meeting by considering the pre-slots of these 10 members based on their availability, based on their deadlines, different deadlines given to these members, and based upon their working. So if I ask this one by giving different schedule of these 10 team members, what regular AI is going to do? It is going to show you different available slots. But is it going to book everything for you? If it is an online meeting, it is not going to create a Google Meet link. It is not going to book a offline meeting for booking different kind of accommodations and a meeting hall. Nothing will be done by the agentic AI. But when you go for agentic AI, what we are expecting, it is understanding the goal. By understanding that, I want to schedule a 1 hour meeting, it will check your all the calendar of all the 10 members, see their deadline, see their time zones. If no perfect time is found, then it is going to negotiate with different people by stating that all other people have agreed to this time, you may be agree this particular time. Okay, it is also explaining that why this slot is more suitable. It is sending the invitation, it is reserving the room, everything will be done by this agentic AI platform. Okay, so it is taking ownership. That's why we say that it is a self-directed behavior. It is a self-directed behavior. It is designing your goal, it is defining your sub-goal and achieve each and every sub-goal just like a end-to-end process. That is the reason why agentic AI is considered as one of the future technology. Now, these are the common steps followed by all agentic AI. Understanding your goal, setting your goal, executing your things, and learning from the environment. No doubt, agentic AI may not perform well in the initial process, but over a period of time now, ChatGPT is able to generate most of the content, although the content is unreliable. But when there is not a time critical application or mission critical application or the application which is related to the life of human being, there you can use ChatGPT. There is no issue. In the similar mission, it is learning from different type of actions. What is the benefit we are going to get? Time is saved, right? If everything is taken care by the agent, the time is saved. Next, as it is a human agent, the commissioning charge is more, right? But if you go for agentic AI, it is done by the system, so it is the cost is a little bit reduced. Okay, and it is going to find more matches compared to a human agent. Human agent do based upon its knowledge, but when you develop a AI system, that is more mature than the human being because it has lot of cases to consider. And whether it is a single, it is solving the problem of a single user or 1 lakh user or 1 billion user or 1 million user, doesn't matter. So scalability is open and continuous learning procedures. These are the various benefits you can get in agentic AI. Now question arises that how agentic AI is different from generative AI. Is it a replacement of generative AI? The answer is no. Because when you go for generative AI, what is your input? Your input is you are putting a question or after that you are giving different prompt. And your objective is to generate the content. And LLM help us to generate the content. But those models are not updated regularly. Like if you type in ChatGPT, how many faculties are there in Department of CSE NIT Warangal, you check and at the end of the talk you can tell me, it is not showing the right number. Why it is not showing the right number? Because the public domain where it is available, that is holding the old data. But when you go for agentic AI, it is just considered as a superset of generative AI. That's why I told you, agentic AI is taking the help of LLM, it is taking the help of machine learning, it is taking the help of enterprise automation. So not only it is generating the content, but also look into different kind of external actions. Like booking the ticket is an example of a external actions. So one of the website you can visit if you are interested, that is called as Lang Graph. workflow is an example of agentic AI. So for example, somebody will say that I have $1,000, I want to buy the stock and I want to sell these stocks in 5 days and I need a minimum profit of 50%. That is my goal. So if you go for our generative AI, it is going to take the YT finance data. LLM is trained using YT finance data and it is going to give you result. But when you go for agentic AI, it is not only dependent on this YT finance data, but also focuses on the current news and development. Based upon that, it is going to suggest you which stock is more suitable and you can get more profit. These are some of the agentic AI framework, like one of the popular framework which supports multimodal agent and workflow, that is called as PyData. PyData is a framework where multiple agents can be grouped together and can perform different type of dependent and independent activity. Similarly, Microsoft is having a agentic AI platform called as Autogen. LangGraph is a platform. LangFlow is a platform. You can explore one of these platforms to build the agentic AI framework. So, if you compare these two, while generative AI is based upon the content creation, agentic AI is based upon the autonomous agent. Agentic AI is a autonomous agent, where it is a generative AI is creating the content. Like that, you can see it is not real-time basis, but agentic AI is real-time basis. It can take different kind of actions, but generative AI cannot take a lot of actions. There are several applications, not only in education, not only in healthcare, in several applications where initially it can be applied for the applications which is not life-threatening process, but later point of time, once it is learned from the environment, we can apply to the applications where we can have such type of mission critical application. Like if you go for ADAS system, advanced driver assistance system, or driverless car system, we can apply in that particular domain. So there are different type of design patterns you can find in agentic AI, like dividing a goal into sub goals. If goal is not solvable, I am dividing the goal into sub goal and I am solving that. Reinforcement learning is an example. Like I can go for a reward and penalty based upon the agent behavior. Multi-agent coordination. One agent can perform one action, another agent can perform other actions. Maybe two actions are dependent or independent. In that case also I can go for multi-agent coordination. Okay, so but other effects also you need to think about, right? Like if agent is autonomous, agent is having self-directed behavior, whether we can control that particular agent or not. What about the security issues with respect to the agent? What about the privacy issues? Whether it can be applied in the supply chain optimization, starting from a raw product to the finished goods. So all these cases is quite challenging when we are integrating agentic AI platform to solve this type of problem. So risk will be always be there. Like one of the example I'll tell you, all of you have seen the robot movie by Rajinikanth. So assume that robot is considered as agentic AI. Okay, robot is having autonomous behavior, right? So earlier you would know that agents do not have any feelings, right? But if feelings comes to the robot, then what it can do, right? It may lead to some threats also. It may lead to loss of human control also. That type of problem can also happen in agentic AI. These are some of the risks and challenges with respect to the agentic AI. So it should not be deployed into the environment which is leading to such type of environment. Yeah, ethical AI development is more important. It can do some non-ethical works also. So we have to ensure that it is doing some ethical work, right? So robust security measures, right? If I want to prevent unauthorized access, cyber threats, nowadays many threats happens with respect to the AI. Threats can be generated by these particular models also, right? So we have to ensure that such type of unethical works are not done by the agentic AI platform. And human oversight is also one of the challenge, right? Human oversight. If something go beyond the capacity of the human being, then we cannot make this agentic AI a successful environment. So this is an agentic AI system where you can see a user making a request to an AI agent. And this AI agent is responsible to respond to this particular user request. But behind this particular AI agent, you have multiple other agents. For example, you can see one agent is deployed for perception, another agent may be deployed for cognition, another agent may be done for actions. And these agents may work autonomously, or these agents may be also applied when there is a dependent applications. So once they are generating different type of decisions, they have to consolidate, they have to return this to AI agent, and AI agent has to consolidate this and return the result to the user. So future of the AI is nothing but integrating agentic AI into various autonomous environment or different cyber physical system, AI human collaboration, which is also the future of human human computer interaction. Then I'll show you one of the example where agentic AI is applied to solve the scheduling problem. Assume that there is a manufacturing industry, and this manufacturing industry is having 10 different tasks, and we have 3 different machines. There are 10 different tasks. I have to assign to 3 different machines. So I need to complete all these 10 tasks before the deadline. I need to balance all these machines, and in case of any failure in the machine, it need to reschedule to other machine. These are the different deadlines that are given to different tasks, and each machine can work for a maximum of 8 hours per day. So this case, you can see the total number of hours of these 10 tasks is 23 hours, but the maximum number of hours that is available with 3 machines is 24 hours. So there is a feasible solution. So what agentic AI is going to do, it has assigned some tasks to different machines and found that one of these machines is having more than 8 hours time. So it is considered as a overload machines. It is considered as a overload machines, which is not a feasible solution. Then it tries to balance this load, which is not exactly 8 hours, but it is managing that with close to 8 hours, right? And in case of there is a failure in the machine, for example, let's say a particular machine 2 is breakdown, then what it is going to do? It has to reschedule the task that is assigned to the machine 2 to other machines. So this scheduling of 10 different tasks into 3 different machines, if you see for the manufacturing industry, and this response of this agentic AI is done within the less than 1 second, within 1 second. So it is able to assign all the 10 tasks, and the 9 tasks are completed within the deadline. So utilization of the machine is 87%. The scheduling is generated by this agentic AI platform with a very minimal time. So that is the advantages we are going to get in the agentic AI platform. Okay, so it is also goal directed. It is autonomously acting. It is perceiving the environment, adapting to different environment, and it is having resilient behavior in the sense that if any something goes beyond the normal thing, then also it is trying to balance that thing. Okay, so as in conclusion, what I can say here, agentic AI is revolutionizing the automation beyond the simple process. So many businesses are adopting this one for enterprise automations, but it is in the initial phase. So upcoming 5 years, we are going to see there is a rise in the agentic AI platform. These are some of the good research paper. Some people are stating that please suggest some textbook related to agentic AI. But I'll suggest you that you go through these initial articles, which gives a deeper view than agentic AI, because you will find most of the books in agentic AI is nothing but edited books. Okay, and that will not give you a complete idea about the agentic AI. Although some books you can find in Amazon, like Building Agentic AI System by A. Biswas. That is also a good book, or Agentic AI with multi-agent system. Okay, that also you can explore. But my suggestion is that apart from the book, you go through the research paper which are recently published, which will help you to understand the agentic AI framework. Yeah, thank you everyone. This is all from my side. If you have any question, you can ask. Okay, somebody is asking, before taking its own decision, means agentic AI decision, it need to ask the user to proceed or not to proceed. It will definitely ask. It will definitely ask, but it is again depending upon what kind of privileges you have given to agentic AI. That's why I told you it is limited supervision. It is not no supervision. It is definitely a limited supervision. Okay, any more question, because we are running out of time? I am extremely sorry because I think some of you are waiting for dinner.
It is very interesting, sir. That's why don't say sorry to us, sir.
Yeah. Okay, any
Anyone
more
has
question?
any questions?
Okay, some people are asking PPT. I'll share with Professor Madhuri madam as well as Rasmita madam. So you can collect, they can post in the group.
Okay, sir, sure.
Okay, if there is no question, thank you everyone. Thank you
So
for
thank you so much, sir.
Thank you so much, sir. Thank you so much for the insightful session, sir. Thank you.
Yeah, thank you.
Thank you so much, sir.
Dear
Thank you.
participants, we are closing today's session. Again tomorrow at 6:30 p.m. Kindly join the day to FDP. Thank you all.
I think tomorrow is 6 p.m. madam, not 6:30.
Sir, actually, sir has some important work. Sir said me to
Okay.
schedule from 6:30, so we are
Yeah,
announcing.
fine.
Yes, sir.
Fine.
Thank you, sir.
Thank you, sir.
No,